In this class, we are going to talk about trigonometry. We're going to go over what is meant by trigonometry, trigonometric ratio, complementary angle, Pythagoras Theorem, inverse trigonometric ratio, and another aspect of trigonometry. The big question is, what is trigonometry? You see, in mathematics, when we talk about trigonometry, we are trying to study the relationship that exists between the sides and the angles of a right angle triangle. Are you getting it? The study of the relationship between the sides and the angles, the relationship that exists between the sides and the angles of a right angle triangle, that is what we call trigonometry. Are you getting it? So in this topic, we are mainly concerned about triangle, and the type of triangle that we're going to be specializing on is a right angle triangle. Don't forget, in plane geometry, like in plane shape, we have various types of triangle. We have equilateral triangle, we have isosceles, we have scalene, and others. But here we are mainly concerned about a triangle that look like this. We are concerned about this kind of triangle. Are you getting it? This triangle that you see here is a right angle triangle. A right angle triangle is a kind of triangle that has one of its angle equals to 90 degrees. Do you understand? So anytime you come across a triangle that look like this, anytime you come across a triangle of this type of triangle is called a right angle triangle. Are you getting it? Now, having understand what is meant by trigonometry, let us look at how to identify the size of the sides of this right angle triangle. Okay, there are three sides in a right angle triangle. We have the hypotenuse side, hypotenuse sides. We have hypotenuse side. Please pay attention. We have the hypotenuse side, we have the opposite side, we have the opposite side, and we have the third side as the adjacent sides. Okay, these are the three sides that we have in this triangle. Now we want to look at which side is the hypotenuse. We want to look at the opposite side, and we want to look at the adjacent side. Okay, now don't forget that a triangle has three sides and they have three angles. You understand? So let's put one angle here. Let's call this one angle theta. Do you understand? Now we want to focus on hypotenuse now. The hypotenuse side is the side that faces angle 90 degrees. Do you understand? Don't forget that I told you that this one that you see here, this signature, this square that you see in this triangle is called 90 degrees. Are you getting it? Now the side that faces this angle is the hypotenuse side. Do you understand? Okay, this is side A. Let's call this one side A. Let's call this one side B. Let's call this one side C. Now, which side faces this angle? The side that faces this angle is the side B. So side B is the hypotenuse side. Do you understand? Hypotenuse side. The hypotenuse can be shortened by using HYP. You understand? HYP, hypotenuse. Do you understand? Okay, the side that faces the right angle, the angle 90 degrees is called the hypotenuse side. Now there are other two angles in this triangle. There one angle here, and we have this angle. Now I want you to pay attention here. We have known that the side that faces angle 90 degrees is what? Is the hypotenuse side. Now how do we get the opposite side? The opposite side is the side that faces the angle that we are considering. Do you understand? Now listen, I told you that this triangle consists of three angles. You understand? One is 90 degrees. This angle is 90 degrees. Do you understand? And that is why we call it right angle triangle. Are you getting it? So this one is 90 degrees. The side that faces the angle 90 degrees is called the hypotenuse. Now back to the opposite. The opposite is the side that faces the angle that we are considering. You understand? Apart from the right angle, there are other two angles in this triangle. One of the angle is this, and the other angle is this. Now we are focusing on this angle. The side that faces this angle is opposite. You understand? It's the opposite side. So let's proceed. If you trace it, you will discover that this is the side that faces this angle. That means that this side is the opposite side. Opposite. Okay, opposite. This is the opposite side. Are you getting it? Now the third side is the adjacent side. So if this is the hypotenuse and this is the opposite, then side C will be the adjacent. Do you understand? ADGJAC, adjacent. Do you get it? So you can see that it's simple. Now let us try another one. Let's say we have a right angle triangle of this kind. Let's try another one. And this angle is 90 degrees. Now you are I want to try this, okay? Let's call this one angle X, okay? Let's call this one angle X. Now, what is the adjacent side? What is the opposite side? What will be the hypotenuse side? Don't forget that I told you that the hypotenuse side of a right angle triangle is the side that faces the angle 90 degrees. And I told you that this symbol that you see here means 90 degrees. So now, what is the hypotenuse side of this right angle triangle? Well, the hypotenuse side is this side, okay? Hypotenuse side. Hypotenuse. This is the hypotenuse, okay? Because it is this side that faces this angle 90 degrees, okay? Now, having identified the hypotenuse side, what is the opposite side? Don't forget that we are considering angle X, okay? We are focusing on angle X now. And I told you that the side that the angle that we are considering points to, that will be the opposite side, you understand? The side that faces the angle that we are focusing on, that will be the opposite side. So since we are considering angle X, that means that the opposite side is the side that faces the angle that you are considering. So this will be the opposite. Do you get it? Okay, this will be the opposite. And why the third side will be the adjacent, okay? Adjacent. So you can see now it's easy to identify this one. Now, what if you are given something like this? What if you are given something like this? Okay, look at this. What if you are given something like this and you are asked to identify the hypotenuse side, the opposite side, and the adjacent side? Okay, let me call this one side A, side B, and side C. Okay, you are asked to identify the hypotenuse side, the opposite side, and the adjacent side. Now, don't forget the steps. Hypotenuse side is the side that faces angle 90 degrees, you understand? And the angle 90 degrees is this angle. Are you getting it? Now, which side faces this angle? The side that faces this angle is this side, you understand? So the hypotenuse side is what? Is B. Do you get it? So this is the hypotenuse side. Let's shorten it, hypotenuse. Okay? Now, since we are focusing on angle theta, look at it. We are focusing on angle theta. Now, the side that faces the angle that we are focusing on, the side that faces the angle that we are considering, that side is the opposite side. Do you get it? So now let us trace it. This side will be the opposite, okay? Opposite. While the third side will be the adjacent, okay? Adjacent. Do you get it? So that is how to identify the sides of a right angle triangle. Do you understand? Okay, now having understand how to identify the sides of a right angle triangle, let us look at trigonometric ratio. Okay, in an attempt to help us to explain the relationship that exists between all these sides that you have here and the angles that we have in this triangle, we use a mnemonic device known as trigonometric ratio. Are you getting what I'm trying to say? In an attempt to help us to explain the relationship that exists between all the sides in this right angle triangle and the angles, we use a mnemonic device known as trigonometric ratio. Okay, now in some textbook you're going to come across something like this: so ka twa. With the help of this device, we can explain the relationship that exists between the sides and the angles in this triangle. Okay, this one that you see here is called trigonometric ratio. Do you understand? Okay, just pay attention. Now, what is the meaning of so ka twa? You see, let's start with this one. So simply means the sine of the angle. Okay, we have theta here, don't forget. Now, this so means the s in this place is sine. You understand? Sine. Please pay attention. The s that is present here is known as sine. You understand? Sine. And the o that is present here is known as opposite. You understand? Opposite. And the h that is present here is known as the hypotenuse. Okay? Hypotenuse. Do you understand? Okay? Now, according to this one, sine of the angle that we are focusing on, we are using like sine theta now. You understand? Sine theta is equals to opposite over hypotenuse. Opposite over hypotenuse. Hypotenuse. Sin theta equals to opposite over hypotenuse. Now listen to me carefully. We are dealing with this one, the first mnemonic device. So, you understand? Now, let us focus on the second one. We have car. You understand? Car. C-A-H. Car. C-A-H. C-A-H. Okay? Now, you know that this one that you see here, C stands for cosine. You understand? Cosine. And H stands for adjacent. 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 YH stands for hypotenuse. You understand? Hypotenuse. Okay? So, now from this one, cos theta, cosine or cos theta, you understand? You see, the short form of cosine is cos. You understand? So, just take the three words, the first three words. The first three alphabets, sorry. That is cos. You understand? C-O-S. Cos theta will be equals to the adjacent, which is this adjacent over hypotenuse. Okay, hypotenuse. Now, do you understand? Okay, now we have the last one, which is toi. So, ka, toi. We are done with so. We are done with ka. Now we want to look at toi. Toi, the T, please pay attention. The T that is present in toi, T-O-A. The T that is present in this T represents tangent. You understand? Tangent. Tangent. Then the O represents opposite. Do you understand? Opposite. And the A represents adjacent. Adjacent. Okay, let me write it very well. Okay. Let me write it very well. The A represents adjacent, okay? This will be adjacent. Adjacent. Okay, now, according to toi, tan theta, please pay attention. Tan theta, don't forget that theta is the angle that we are considering. You understand? Angle that you are focusing on, that is theta. Tan theta equals to opposite over adjacent. Okay, now look at this. We have so, ka, toi. Now, opposite is part of the sides of the right angle triangle, right? Yes. Hypotenuse is also part of the sides of the right angle triangle. Yes. Adjacent is also part, right? Now, look at this. We have theta. Theta is the angle that we are focusing on, right? The sine of the angle that we are focusing on is the opposite side all over hypotenuse side. Are you getting it? The cos of the angle is the adjacent side all over hypotenuse side. And the tan of the angle that we are considering, which is theta, is what? Opposite over adjacent. Are you getting it? Now let's go back to this right angle triangle. We know that this is the hypotenuse side because that is the side that faces angle 90 degrees. We know that this is the opposite side because that is the side that faces the angle that we are considering. That is the side that faces the angle that we are focusing on. Now, the third side is the adjacent side, right? Yes. Based on this, what will be the sin theta in this place? Hello, please pay attention. Focus on this right angle triangle now. What will be sin theta? Sin theta will be opposite. The opposite is what? A. You understand? So sin theta will be what? A all over the hypotenuse, right? A all over hypotenuse. The hypotenuse is what? B. So sin theta will be what? A over B. Do you understand? Okay. Let's proceed. What of cos theta? Cos theta. Cos theta. Cos theta will be adjacent over hypotenuse. What do we use to represent the adjacent? That is what? C, right? So adjacent is C. So I'm going to have cos theta is C all over hypotenuse. The hypotenuse is what? The hypotenuse is B. So cos theta will be C over B. Do you get it? Okay. Now, what of tan theta? Tan theta is what? Opposite over adjacent. Are you getting it? Tan theta tan theta will be equals to opposite. The opposite side is what? A. So I'm going to have A all over adjacent. The adjacent side is what? Is C. So A over C. Now, please pay attention. The summary of what we are discussing is this. If you are given the three sides of a right angle triangle and you're asked to find the sine of the angle, the cos, and the tan, you're going to make use of this mnemonic device, so quatre. And so represent S represents sine theta, you understand? And sine theta is what? Opposite over hypotenuse. Ca is what? Cos theta. Cos theta is adjacent over hypotenuse. And trois, this T represents tangent, O represents opposite, and A represents adjacent. So if you are able to master so quatre, you'll be able to find any trigonometric ratio that you're asked to find. Do you understand? Okay. So let's represent the sides with number. Let's say this is 10 centimeter, and let's say this is let us represent the sides with a number. Okay, let's say this side is 10 centimeter. Let's say this side is 6 centimeter, and the third side, let us represent it as 8 centimeter. Okay, so let this one be 8 centimeter. Oh, this length is let's use this as 8. Let's use this one as 6, because this length is this one is longer than this. Okay, now look at what we have on the board. Let's say we are given this kind of question. Now we are asked to find the value of sine theta, cos theta, and tan theta. Okay, let me erase this. We are asked to find the value of sine theta, cos theta, and tan theta. How do we determine the value of cos theta? Let's start with sine theta. Don't forget that according to sine of the angle, which is theta, is what? Opposite over hypotenuse, right? Now, what is the opposite side of this right angle triangle? The opposite side is 8 centimeter. So that's what? 8 centimeter all over hypotenuse. The hypotenuse side is the side that faces the angle 90 degrees. So the hypotenuse side is this side. That will be what? 10 centimeter. Okay? 10 centimeter. Are you getting it? So this will be what? 8 over 10. 8 over 10 can be reduced to what? That is 4 over 5. Okay? That is 4 over 5. Do you get it? Okay? Now, let us focus on the cos theta. What will be the value of cos theta? Cos of the angle is what? Adjacent over hypotenuse. Now, adjacent is what? 6 centimeter. Okay, so I'm going to have 6 centimeter all over the hypotenuse. The hypotenuse is what? 10 centimeter. So I'm going to have all over 10 centimeter. This can be reduced to 3 all over 5. Okay, so I'm going to have 3 over 5. That is the cos of the angle. That is cos theta. Now, what of the tangent? The tan theta is what? Opposite over adjacent. The opposite here is what? 8 centimeter. So I'm going to have 8 centimeter all over adjacent. Adjacent is what? 6 centimeter. So I'm going to have over 6 centimeter. Okay, what is the correct answer? That will give us, this can be reduced to 4 over 3. 4 over 3. Opposite over adjacent. Now, you can see that is how that is the importance of this concept in trigonometry. Okay, so I want you to master this because you are going to use it as we progress in this topic. Do you understand? Now, having understand trigonometric ratio, let us look at inverse trigonometric ratio. Okay, the inverse of a trigonometric ratio. That is the next concept that we are going to talk about. Okay, let us proceed. We've talked about sine. We've talked about cosine, that is cos, and we have talked about tangent. Okay, now there are 3 other concepts that we are going to talk about. Those 3 are called the inverse of the trigonometric ratio. Do you get what I'm trying to say? You know that when we start the discussion, we talk about sine, cosine, and tangent. The inverse of these 3 trigonometric ratio is what we want to talk about now. Are you getting it? Now, the inverse of sine. What is meant by inverse? Inverse simply means reciprocal. You understand? Are you getting it? Inverse simply means reciprocal. So the inverse of sine will be what? 1 over sine. Are you getting it? Okay. The inverse of sine Let's start with sine. The inverse of sine theta, let's use sine theta. The inverse of sine theta will be what? The inverse will be 1 over sine theta, right? Please pay attention. 1 over sine theta is known as cosecant. You understand? Cosecant. Cosecant. I'm going to explain. Just pay attention. These are the three important trigonometric ratio. You understand? Now, taking the inverse of these three trigonometric ratio will give us to will lead us to inverse. Are you get what I'm trying to say? When you take the inverse of sine, you're going to have cosecant. You understand? And cosecant can be shortened to cosec. Cosec. Are you getting it? Just master it, okay? Listen to me carefully. The inverse of sine will be 1 over sine theta, right? And 1 over sine theta is cosecant. You understand? And it can be shortened as cosec. Now, let me put theta, cosec theta. Now, let's look at cos. Cosine. The inverse of cos, please pay attention, it's simple. The inverse of cosine will be 1 over cos theta, 1 over cos theta. Okay? Now, 1 over cos theta is also known as secant. You understand? Secant. And that will be what? Sec theta. Sec theta. Do you get it? Now, let us look at tangent. You understand? Tangent. Tangent. Tangent, okay? The inverse of tangent will be what? 1 over tan theta. And that will be cot. Are you getting what I'm trying to say? That will be cotangent. So this will be cotangent. It's called cotangent. That will be cot. Shorten it. Cot theta. Now, listen to me carefully. The reason why I take you through this is because in trigonometry, you might come across cosecant, secant, and cotangent, and they might not write it in full. They might shorten it as maybe cosec theta, sec theta, or cot theta. They are still talking about the same thing. Okay? When you take the inverse of sine theta, you're going to have cosec theta. Do you understand? Sec theta simply means the inverse of cos theta. Why tan theta, cot theta simply means the inverse of tan theta. Master it again. Okay, let me explain again. Inverse trigonometric ratio simply means that taking the reciprocal of the trigonometric ratio. Are you getting what I'm trying to say? Now, the trigonometric ratio that we discuss are what? Sine, cosine, and tangent. Now, when we take the inverse of sine, we're going to have a product. The product that we are going to have is cosec. You understand? And it's also known as cosecant. Cosec theta. Are you getting it? Now, when you take the inverse of cosine, you're going to have a product. The product is sec theta or secant. You understand? The short form of secant is sec. Now, when you take the inverse of tan theta or tangent, you're going to have cotangent, and the short form is cot. Do you understand? Okay, so please master those three. Now, let's go back to the right angle triangle that we are given. Please pay attention. Let's go back to the right angle triangle that we are given. Sine theta is what? 4 over 5. We know that sine is what? Opposite over hypotenuse. Are you getting it? And the opposite side is 8, while the adjacent hypotenuse side is what? 10 centimeters. So, and 8 over 10 will give us 4 over 5. Now, what if you are asked to find cosec theta? Cosec theta. Cosec theta. What if you are asked to find cosec theta? Don't forget that I told you that the inverse of sine theta will give us cosec theta. You get it? We are still on this. The inverse of sine theta will give us cosec theta. Now, if sine theta, listen to me. If sine theta is what? Opposite over hypotenuse. Cosec theta will be what? Cosec theta will be 1 over opposite over hypotenuse. Please pay attention. It's simple. Don't forget that I told you that cosec theta is what? 1 over sine theta. And we know that sine theta is what? Opposite over hypotenuse. That means that cosec theta will be 1 over opposite over hypotenuse, because opposite over hypotenuse is what? Sine theta. Are you getting it? Just pay attention. It's simple. Let's go back. this is cosec theta. Are you getting it? Cosec theta simply means the inverse of sin theta. And we've learned that sin theta is what? Opposite over hypotenuse. Listen, opposite over hypotenuse. That is sin theta. Cos theta is what? Adjacent over hypotenuse. Are you getting it? And tan theta is what? Opposite over adjacent. Are you getting it? Now, we know that sin theta is opposite over hypotenuse, and cosecant is the inverse of sin theta. Are you getting it? Now, the inverse of sin theta will be 1 over opposite over hypotenuse, because sin theta itself is opposite over hypotenuse. Do you get it? Now, let's go back to the question. We want to find the value of cosec theta. Cosec theta will be equals to 1 over opposite over hypotenuse, right? Now, that will give me 1 divided by opposite over hypotenuse. Now, sin theta is 4 over 5, right? So that will be what? 1 divided by 4 over 5. That will give me 1 times 5 over 4, because you know that if this division sign changes the multiplication sign, the numerator will become the denominator, and the denominator will change to numerator. So that will be what? 5 over 4. 5 all over 4. So cosec theta is what? 5 centimeters all over 4. Do you get it? Okay. Let us look at sec theta. Sec theta. Sec theta sec theta will be equals to, now what will be the answer to sec theta? Sec theta will be the inverse of cos, right? And we know that cos theta is what? 3 over 5. Please pay attention. We know that cos theta is 3 over 5. Now, sec theta will be equals to 1 over cos theta, right? Cos theta. And sec theta will be equals to 1 over cos theta is what? 3 over 5. That will be what? 1 over 3 over 5. So that will be what? 5 all over 3. Do you know how I got 5 over 3? Just like what we did for cosec theta. That will be what? 1 divided by 3 over 5. Are you getting it? That will be 1 multiplied by 5 over 3. Do you understand? Because if this division sign changes to multiplication sign, the numerator and the denominator will be changed. Are you getting what I'm trying to say? The denominator will become the numerator. That is why I have 5 here, and the denominator will become the numerator, while the numerator will become the denominator of the fraction. So that is why I have 5 here and 3 at the denominator. So that will be sec theta will be what? 5 over 3. 5 all over 3. Do you get it? Now, what will be the value of tan theta? What will be the value of cos theta? Cos theta. Cos theta. Cos theta will be 1 over tan theta, you know? 1 over tan theta. And 1 over tan theta. Tan theta is what? 4 over 3. That will be what? 1 over 4 over 3. And that will be what? 3 over 4. Okay? Just like what we did for both cosec theta and sec theta. So cos theta will be what? 3 over 4. Now you can see the relationship between this trigonometric ratio. This theory that you have here is called the inverse of the theory that we have at the bottom, the first theory. Are you getting it? The theory that we have here is the inverse of what we have at the top. We have sine, cos, and tan, right? The inverse of all this is this. Do you understand? Inverse of sine theta is cosec theta. You've heard of inverse in mathematics. Inverse simply means reciprocal. 1 over, are you getting it? Inverse of A is 1 over A. Inverse of B is 1 over B. Inverse of C is 1 over C. Inverse of A over B will be B over A. Now back to this. We have sine theta equals to 4 over 5. The inverse of sine theta is known as cosec theta. And cosec theta will be what? The inverse of this. If you take the inverse of 4 over 5, you're going to have 5 over 4. Inverse of 3 over 5, you're going to have 5 over 3. And inverse of 4 over 3 will be what? 3 over 4. It's just as simple as that. Okay? So that is all on inverse trigonometric ratio. Let's consider the question that we have on the board. Given this right angle triangle, we are asked to evaluate sin theta, cos theta, tan theta, cosec theta, sec theta, and cot theta. Okay? we know that sine theta is what? Opposite over hypotenuse. And looking at the diagram, the opposite side is what? Is the side that faces the angle that we are considering. Are you getting it? The opposite side is the side that faces angle theta. So the opposite side is this side. This is the opposite. So since we know that sine theta is what? Opposite over hypotenuse, that would be what? 4 all over hypotenuse. The hypotenuse is 5 because that is the side that faces angle 90 degree. Do you understand? So this is 4 over 5. Now, what of cos theta? Cos theta is adjacent over hypotenuse. You know, cos theta is adjacent over hypotenuse. This is the hypotenuse, and this is the adjacent. Do you get it? Okay. The adjacent is 3. So cos theta is 3 over hypotenuse. The hypotenuse is 5. So that will be 3 over 5. What of tan theta? Tan theta is what? Opposite over adjacent. Abi? Now, the opposite side is 4. So I'm going to have 4 all over adjacent. The adjacent is 3. So I'm going to have 4 over 3. Now, what of cosec? Cosec theta is the inverse of sine theta. You understand? And the inverse of sine theta is what? Hypotenuse over opposite. Do you get it? Let me explain. I've already explained it in the previous example. The inverse of cosec is what? 1 over sine theta. And sine theta is what? Opposite over hypotenuse. The inverse of opposite over hypotenuse is what? Hypotenuse over opposite. You understand? Hypotenuse over opposite. Let me put it. Hypotenuse over opposite. And this one, the inverse of cos theta will give us what? Cos secant. You understand? Or sec theta. So the inverse of adjacent over hypotenuse is what? Hypotenuse over adjacent. Hypotenuse over adjacent. The inverse of tangent is what? Cot. You understand? So to get cot theta, I have to take the inverse of opposite over adjacent. So the inverse of opposite over adjacent will be what? Adjacent over opposite. Adjacent over opposite. Do you understand? Okay, now let's go. Since we know that cosec theta is hypotenuse over opposite, the hypotenuse is 5, so I'm going to have 5 all over opposite. The opposite is 4, so I'm going to have 5 over 4. Okay, what of sec theta? Sec theta is the inverse of cos theta. That will be what? Hypotenuse over adjacent. The hypotenuse is 5, so I'm going to have 5. And the adjacent is what? 3. So I'm going to have 5 over 3. What of cot theta? Cot theta is the inverse of tan theta. And tan theta is what? Opposite over adjacent. Hence, cot theta will be what? Adjacent over opposite. You understand? The adjacent is 3, so I'm going to have 3. And the opposite is 4. So I'm going to have 3 over 4. 3 over 4. What if you are asked to find sine theta minus cos theta? Pay attention. Let's say you are given another question. Sine theta minus cos theta. Now don't forget that sine theta is what? 4 over 5. Just put it. 4 over 5 minus cos theta. Cos theta is what? 3 over 5. So put it. 3 over 5. Okay. What is the LCM? The LCM is what? 5. So I'm going to have 5. 5 divided by 5 is what? 1. 1 times 4 is 4. Do you understand? 5 divided by 5 is 1. 1 times minus 3, that is what? Minus 3. So I'm going to have 4 minus 3 is 1. So I'm going to have 1 over 5. Do you get it? So no matter how they manipulate or reframe the question, if you are able to comprehend what we are discussing, you'll be able to answer any question as regarding trigonometric ratio and inverse of a trigonometric ratio. Do you understand? If you understand, reverse the video and listen to the explanation again, okay? So now, another concept that we are going to talk about is Pythagoras Theorem. You understand? You are going to need this concept because most time before you can proceed to evaluate any of this kind, there are some questions that will be required to use Pythagoras Theorem to find one of the side. Okay? Now, so I want to pay attention. According to Pythagoras Theorem, let me erase this please. Let us erase this. Pythagoras Theorem. Pythagoras Theorem. Pythagoras. This theorem is very important as far as trigonometry is concerned. According to this theorem, the hypotenuse side, the square of the hypotenuse side is equals to the sum of the square of the other two sides. That is Pythagoras theorem. Are you getting it? The square of the hypotenuse side is equals to the opposite squared plus the adjacent squared. Okay? Now let's go. according to this theory, the square of the hypotenuse is equals to the sum of the square of the other two sides of the right angle triangle. Now let's check. We want to check if this is true. We're going to use this triangle that we have here. Any triangle that we're going to call a right angle triangle must satisfy this condition. You understand? When we square the hypotenuse, it must be equals to the sum of the square of the other two sides. Okay? If you have a right angle triangle that doesn't satisfy this condition, we cannot call it a right angle triangle. You understand? Any right angle triangle must satisfy this condition. The square of the hypotenuse side must be equals to the sum of the square of the other two sides. Eventually, if you are given a right angle triangle that doesn't satisfy this condition, SOHCAHTOA will not work for that right angle triangle. You understand? Because in SOHCAHTOA, in trigonometry, no matter the trigonometric ratio that you use, you must result into the same value of theta. We are going to talk about it more when we get to how to find theta. You understand? Don't worry, we are still coming there. Now, let's go back to what we are discussing, Pythagoras Theorem. Pythagoras Theorem states that the square of the hypotenuse side of a right angle triangle is equals to the opposite squared plus the adjacent squared. Do you understand? Okay, let us check if this is true. The hypotenuse of this right angle triangle is what? Is 5. So I'm going to have 5 squared is equals to, now, what is the opposite? The opposite is what? Is 4. So I'm going to have is equals to 4 squared plus adjacent squared. The adjacent is 3. So I'm going to have plus 3 squared. 5 squared is what? 25. So I'm going to have 25 is equals to 4 squared. 4 squared is 16. 16. Okay. What of 3 squared? 3 squared is 9. So I'm going to have 9 here. Okay. 25 is equals to 16 plus 9. That will give us 25. You can see that it satisfies the condition because when we substitute the values of 4, 5, and 3 as the opposite hypotenuse and adjacent, we have the same answer at the left hand side and the right hand side. Now, that means that this law is true. You understand? The reason why I delve into this is because now, let's say we are given a question. Let's say we are given a question whereby you are not given the adjacent and you are now asked to calculate the you are asked to find sin theta, cos theta, and just like the previous example that we did. Let's say you are given this question. We have already talked about Pythagoras Theorem. This law, this is Pythagoras Theorem. The square of the hypotenuse equals to opposite squared plus the adjacent squared. Now, let's say you are given this kind of question. You are asked to evaluate sin theta, cos theta, and also we have to evaluate cot theta, and so on. You understand? Let's say you are given this diagram. Now you are asked to evaluate sin theta. This is the first question. Find sin theta, cos theta, and find cot theta. Now you cannot find sin theta without knowing the you cannot find tan. Okay, let me put more tan theta. Okay, in this diagram you can get sin theta, right? Yes, because sin theta is what? Opposite over hypotenuse, and the opposite is this, while the hypotenuse is what? This. Okay, that is what? 4 over 5. 4 over 5. What of sin theta, cos theta? Sin theta, cos theta means the product of sin theta and cos theta. Now, before we can get cos theta, we need the adjacent. That is where Pythagoras Theorem comes in. You understand? Because by using Pythagoras Theorem, we can get this side. You understand? According to Pythagoras Theorem, the hypotenuse squared is equals to opposite squared plus the adjacent squared. Now, what we are looking for is the adjacent. So, let us try. Hypotenuse is what? 5. So, I'm going to have, using Pythagoras Theorem, we need the adjacent side. Using Pythagoras Theorem. Okay, hypotenuse is what? Let us represent the adjacent as x. Okay, I'm going to have hypotenuse, which is what? 5 squared equals to opposite squared, that is what? 4 squared plus the adjacent squared, that is what? X squared, because we have already represent the adjacent as x. Okay, 5 squared is 25. I'm going to have 25 equals to 16 plus x squared. Okay, is that not it? Yes. For this, I'm going to have 25 minus 16 equals to x squared. Okay, because when this 16 crosses the equals to sign, the positive sign is going to change to negative. Okay, and you can subtract 16 from both sides. You can do it the other way. Okay, 25 minus 16 is 9. 9 equals to x squared. Okay, x squared equals to 9. So x equals to the square root of 9. X equals to 3. Okay, so the adjacent is 3. Now, having gotten the value of the adjacent, we can now progress to calculate the value of sin theta cos theta. Okay, please pay attention. It's simple. I just used that example to help you to understand the importance of Pythagoras theorem in what we are talking about. Okay, so now having gotten the adjacent as 3, we can now proceed to calculate the sin theta cos theta, because cos theta will be what? Cos theta will be adjacent, which is 3 over what? Adjacent over hypotenuse, which is 3 over 5. Okay, hence sin theta cos theta will be what? Sin theta is 4 over 5 times cos theta, which is 3 over 5. 3 over 5. 4 times 3 is 12. 12 over 5 times 5 is 25. So this will be what? 12 over 25. That is the final answer. Okay, what of cos theta? Cos theta is the inverse of tan. Okay, now if tan theta is opposite over adjacent, cos theta will be what? Adjacent over opposite, right? So the adjacent is what? 3. So this will be what? 3 adjacent over opposite, 3 over 4. Okay, and tan theta will be what? 4 over 3. You can see the importance of Pythagoras theorem. Now imagine, listen to me carefully, we are not given this side. Now we have to use Pythagoras to get this side, because we cannot evaluate the value of cos theta, tan theta without knowing the adjacent side. So you can see the importance of Pythagoras theorem. Okay, so depending on the structure of the question, you might need Pythagoras theorem to find one of the side. Okay, just know that the hypotenuse squared is equals to the sum of the square of the other two sides. Okay, before we proceed to the next concept, let's look at questions that combine both Pythagoras theorem and trigonometric ratio together. Let's consider this question. If tan theta equals to 8 over 15, evaluate sin theta plus cos theta over cos theta multiplied by 1 minus cos theta. Evaluate. We are given that tan theta, please pay attention, the solution to that question. Tan theta is equals to 8 over 15. 8 over 15. We are asked to evaluate sin theta plus cos theta. Sin theta plus cos theta all over cos theta multiplied by 1 minus cos theta. Okay, you can see that this is one of the question type that I told you. You can have question in a way, they can give you a question whereby you're going to use Pythagoras theorem, and then before you can find what you are asked to find, you know that tan theta is what? Opposite over hypotenuse. Please pay attention. Tan theta is what? Opposite over adjacent. Sorry, opposite over adjacent. Okay, so this will be what? Opposite. Why this will be what? Adjacent. Okay, so let us construct a right angle triangle for this. In that case, let me call this one theta. Now let's call this one angle 90 degree. The opposite side is the side that faces theta, right? So the opposite side will be what? 8, and the adjacent side is the side that is this side, adjacent, which is 15. How do I know that it is this side? The side that faces angle 90 degree is what? This side. That is the hypotenuse. You understand? So if this is the hypotenuse, the third side will be adjacent. Do you understand? Okay. Now we don't know the hypotenuse. We are only given the opposite and the adjacent. And before we can proceed to calculate sin theta plus cos theta, or before we can solve this question, we need the hypotenuse, because sin theta is opposite over hypotenuse. Do you get it? So the hypotenuse, we need it. And before we can get the hypotenuse, we have to make use of Pythagoras theorem. And according to Pythagoras theorem, the hypotenuse squared is equals to the opposite squared plus the adjacent squared. Okay, now we don't know the hypotenuse. Let us represent it as x. Okay, so I'm going to have x squared is equals to the opposite is what? 8. The 8 squared plus the adjacent squared. Adjacent is 15, so I'm going to have 15 squared. Okay, for this I'm going to have x squared is equals to 64 plus 15 squared is what? 225. Do you get it? Okay, x squared will be equals to 289. Do you understand? Okay, to get the value of x, we have to take the square root of both sides. Okay, so x, which is the hypotenuse, equals to 17, because square root of 289 will give us 17. Now, that means that this side is 17. Okay, now we cannot proceed to evaluate what we are asked to calculate. We have sin theta plus cos theta. In this case now, sin theta will be what? Hypotenuse, opposite over hypotenuse. Now, opposite here is what? 8. So I'm going to have opposite, which is 8, over hypotenuse. Hypotenuse is 17. Now, cos theta is what? Cos theta is what? Adjacent over hypotenuse. Adjacent is 15, so I'm going to have 15. And the hypotenuse is 17, so I'm going to have 15 over 17. That is cos theta. Now, we can now proceed to calculate this. Sin theta is 8 over 17. I'm going to have 8 over 17 plus, please pay attention, plus cos theta. Cos theta is 15 over 17. 15 over 17. That is the numerator. All over cos theta, which is 15 over 17 as well. 15 over 17 multiplied by 1 minus cos theta, which is 15 over 17. Do you understand to this point? You see, before I can solve this question, I need the hypotenuse. Are you getting it? And to get the hypotenuse, we have to use Pythagoras Theorem. Do you get it? And having used Pythagoras Theorem, I got 17. Having gotten 17 as the hypotenuse, sin theta is 8 over 17 because sin theta is opposite over hypotenuse. And cos theta is 15 over 17 because cos theta is what? Adjacent over hypotenuse. Now, since I've known the value of sin theta and cos theta, I go back to what I'm asked to solve, and sin theta is what? 8 over 17 plus 15 over 17 all over cos theta is 15 over 17. This one is here, and cos theta is 15 over 17. I substitute both. What I did was that I substitute both cos theta and sin theta into this. Now, all you have left to do now is to simplify. Okay? Now, let us simplify the numerator. 17, because you're going to take the LCM, right? Yes. Okay? 17, I'm going to have 8 plus 15. Do you get it? Divided by, okay? Let us deal with the bracket first, or the parenthesis. Okay? Take the LCM 17. I'm going to have 17 minus 15. Do you get it? Okay? If you take the LCM of 17 and 1, you're going to have 17. 17 divided by 1, 17. 17 times 1, 17. 17 divided by 17, 1. 1 times minus 15, minus 15. Okay? Now, 8 plus 15 will give us 23. So I'm going to have 23 all over 17 divided by, okay, 15 over 17 multiplied by 17 minus 15 is 2. So I'm going to have multiplied by 2 all over 17. Do you get it? Okay? Now, having gotten to this point, I'm going to have 23. Okay, let me write this. 23 all over 17 divided by, you see, this division sign is what I put here, okay? 15 times 2 is 30. So I'm going to have 30. 17 times 17 will give us 289. So I'm going to have 289 in this place. Now, I'm going to have 23 over 17 multiplied by 289 all over 30, right? Okay? Now, 17 here, 1, 17 here, I'm going to have 17, okay? 17 times 23, that is 391. So I'm going to have 391 all over 30 times 1 is what? 30, okay? So you can leave your answer in fraction, or if you want to change it to mixed fraction, you can also proceed. But depending on the situation, you can put your answer like this. So the simplification of this is 391 over 30. Now, what if you are not asked to find sin theta minus 1? Like another question. Sin theta minus 1 all over cos theta multiplied by multiply 1 minus cos theta. What if you are asked to evaluate sin theta minus 1 all over cos theta multiplied by 1 minus cos theta. You are still going to go the same way. All you have to do is that, since you know that sin theta is what? 8 over 17. I'm going to have 8 over 17 minus 1 all over cos theta is what? 15 over 17, right? So I'm going to have 15 all over 17 multiplied by 1 minus 15 all over 17. Then what you are left to do now is that you have to simplify. So you can see that it's simple. Okay. Now let us take the LCM of the numerator. I'm going to have, what is the LCM of 17 and 1? That is what? 17. 17 divided by 17 is 1. 1 times 8 is what? 8. 17 divided by 1 is what? 17. 17 times minus 1, that is what? Minus 17. Minus 17 all over, okay? The numerator now, we have 15 over 17. 15 over 17 multiplied by, okay, take the LCM. The LCM is 17 as well. 17 minus 15, right? Okay? It's simple. Now from this point, 8 minus 17 will give us minus 9, okay? I'm going to have minus 9 all over 15 over 17 multiplied by 17 minus 15, that is what? 2. 2 over 17. Do you get it? Please pay attention, it's simple. Now, having gotten to this point, all you have to do now is that, okay, let me write this. Minus 9. Oh, sorry, this is minus 9 over 17. Minus 9 over 17. Because the numerator is what? 8 minus 17 is what? Minus 9. Minus 9 over 17 all over the denominator. Now, I'm going to have minus 9 over 17 divided by, now, 15 times 2 is what? 30. I'm going to have 30 over 17 times 17, that is 289. 289. Okay, minus 9 all over 17 multiplied by 289 over 30. Okay, do you understand it to this point? Now, 17 here 1, 17 in this place, 17. I'm going to have this. 17 multiplied by minus 9. That will give us 153, okay? So I'm going to have minus 153 all over 30. In this class, we're going to talk about complementary angle. What exactly do we mean by complementary angle? Complementary angle are angles that are summed up to 90 degrees. Okay, so that means that when we say two angles are complementary, the summation of these angles must be equivalent to 90 degrees. So in complementary angle, we are dealing with angle that ranges from, please pay attention, we are dealing with angles that ranges from 0 degree is less than or equals to theta, theta is less than or equals to 90 degrees. Since the angles that we call complementary angles are angles that ranges between 0 to 90 degrees. I mean, when we have two angles that are complementary, that means their summation must be equals to 90 degrees. Are you getting it? And for complementary angle, please pay attention. For complementary angle, the sine of the angle is equivalent to the cos of 90 degrees minus theta. You know, we are dealing with trigonometry. Are you getting it? The relationship that exists between two complementary angles can be explained using trigonometry. Are you getting it? The sine of the angle is equivalent to cos 90 minus theta. Are you getting it? Where theta ranges from 0 degree to 90 degrees. Are you getting it? Please, it's simple. Just pay attention. Don't forget, I told you that complementary angles are summed up to 90 degrees. Okay? Now, when two angles are complementary, their summation must be equivalent to 90 degrees. That means that the angle that we are talking about, the angles that we are summing together, both of them, if they are going to be equivalent to 90 degrees, that means that both of them must be less than 90 degrees. That is why we are dealing with, that's why I have these values. 0 degree is less than or equals to theta, theta is less than or equals to 90 degrees, okay? So for complementary angle, this identity holds. Sin theta equals to cos 90 minus theta. Don't worry, we are going to look at work example on this, okay? Another one is this. Cos theta equals to sin 90 minus theta. Are you getting it? The first, the second, then the third. Cot theta equals to tan 90 minus theta. The fourth, tan theta is equals to cot 90 minus theta. Just pay attention. Then the fifth one, let's sec theta equals to cosec 90 minus theta. Okay, the sixth, cosec theta equals to sec 90 minus theta. Okay, now for theta, for 0 degree is less than or equals to theta, theta is less than or equals to 90 degree. This identity holds. Are you getting it? So this is how question will comes under this subtopic. You are going to be given an equation. You are not going to have to solve for the variable that is present in that equation. Okay, please pay attention. Sin theta equals to cos 90 minus theta. This means that since theta is less than, theta is greater than or equals to 0, but theta is what? Is less than or equals to 90 degree. That means that let's say theta is 45 degree. Theta equals to 45 degree. I want to explain the relationship that exists between the sine and the cos now. Let's say theta is 45 degree. That means that for this first one, for sin theta equals to cos 90 minus theta. Let's try. Let us check if this rule is correct. If this identity is correct, we want to check. Now, when theta is 45 degree, I'm going to have sine 45 degree equals to what? Cos 90 minus, now theta is 45 degree, so I'm going to have 90 minus 45 degree. Okay, I'm going to have sine 45 degree equals to what? Cos 45 degree. And the simple reason is simply because 90 minus 45 degree will give us 90 degree minus 45 degree will give us 45 degree. Okay, now what is sine 45 degree? Sine 45 degree is 0.7071. 0.7071. Also, if you pause your calculator, cos 45 degree is also 0.7071. So you can see that these angles are complementary. Are you getting it? For a complementary angle, sine of the angle is equivalent to the cos of the angle, cos of 90 minus angle minus the angle that you are given. Okay, cos sine theta, sine of the angle that you are given for theta is what? For theta ranging between 0 degree and 90 degree, the sine of the angle is equivalent to the difference between 90 degree and the angle that you are given, the cos of that value. Are you getting it? Let's proceed to another one. Cos theta equals to sine 90 minus theta. Now, when theta is also 45 degree, you are still going to have cos 45 degree equals to sine 45 degree. That means I'm going to have 0.7071 equals to 0.7071. You can see that it's simple. So all these identity are correct. If you put any values of theta, if you put any values of theta, provided that theta is between the range of 0 degree and 90 degree, you are going to have a complementary angle. Now let us check. If theta is 45 degree, and we have already said that sin theta equals to cos 90 minus theta, that means I'm going to have sin 45 equals to cos 45. If you sum 45 and 45 together, you're going to have 90. Are you getting it? So that is what we call complementary. Angle that are sum up to 90 degree. Complementary. Are you getting it? Okay. Now let us look at work example. We're going to solve work example on all the 6 identities that we have here. Okay. So just pay attention. Given that sin theta equals to cos theta, solve for the value of theta. Okay. Given that sin theta, that's the first question. Okay. Given that sin theta equals to cos theta, what is the value of theta? Okay, that is what we are asked to do. How do we get the value of theta? Now come to these rules. We have sin theta here, we have cos theta here, so you can make use of any of these rules, any of these two rules. Okay, we know that sin theta is equivalent to sin theta equals to cos 90 minus theta. Okay, now that means that I can replace, please pay attention. That means that I can replace cos theta, sin theta as cos 90 minus theta in this equation. Listen to the explanation again. Okay, this is the equation that you are given. Sin theta equals to cos theta. We are asked to find the value of theta. Are you getting it? Now, we know from the complementary identity of trigonometric ratio that sin theta is equivalent to the cos 90 minus theta. So I just bring it out. Okay. Now, instead of sin theta that is present here, I can replace this sin theta as cos 90 minus theta. So I'm going to have something of this kind. Let me use the grey pen. Instead of this sin theta, I'm going to replace it as cos 90 minus theta. So I'm going to have cos 90 minus theta equals to cos theta. You can see now. So we have cos 90 minus theta at the left hand side now. We have cos theta at the right hand side. Now, at this left hand side, what I did is that, this is what I did. I replaced sin theta as cos 90 minus theta, because this identity, from this first identity, sin theta is what? Cos 90 minus theta. So instead of having sin theta here, I replace it as cos 90 minus theta. So I've not done anything, right? Okay. Now, because we have the same trigonometric ratio is present in both sides of the equation now, which is what? Cos and cos. So I can equate their coefficient. Are you getting it? So I'm going to have 90 minus theta equals to what? Theta. It's just as if saying that cos cancel cos. Are you getting it? So we are left with what? 90 minus theta equals to theta. Do you understand? Now, the goal is to find the value of theta. Don't forget. So to get the value of theta, I'm going to collect like terms. I'm going to take this theta to the right hand side of the equation. So I'm going to have 90 equals to this theta. Now, if this negative theta crosses the equals to sign, the sign is going to change to positive. So I'm going to have theta plus theta. Okay? Are you there? So theta plus theta is what? 2 theta. 2 theta equals to 90. To get the value of theta, what do? Divide both sides by 2. So I'm going to have this over 2 and this over 2. Theta equals to 45 degrees. Okay? So the value of theta in sin theta equals to cos theta is what? 45 degrees. You can check you can punch your calculator. Sin 45 degrees is equals 2 over 2 or 0.7071. Cos 45 degrees is also 0.7071. So you can that means that this identity is correct. Okay? Theta is 45 degrees. Let us look at one more example. Given that sin theta equals to cos 40 degrees, find the value of theta. Okay? Given that sin theta equals to cos 40 degrees, we are asked to find the value of theta. Now, how do we get the value of theta? See, let me tell you. You can use this identity. You see, the trigonometric ratio that is present in this equation is what? Is sine and cos, right? So go back to the identity that we have here. Sin theta equals to cos 90 minus theta, or cos theta equals to sin 90 minus theta. You can use any of these two. See, you can use any of these two. Okay? So which one should we use? Let us use the second one. From the second one, we have cos theta equals to sin 90 minus theta, right? This is the second one. Now, I can replace this, pay attention. I can replace the value of cos. I can replace the value of cos theta as this value. Cos theta equals to sin 90 minus theta. That means that cos 40 degree equals to what? Sin 90 degree minus 40. Do you understand? It's simple. Please pay attention. You know, in the previous example, I make use of the first identity, which is this one. Now I am just telling you that you can use any of them, because both trigonometric ratio that are present in the equation is what? Sine and cos. Are you getting it? And if you look at the first and the second identity, sine and cos is also present. We have sine here, we have cos here. We have sine, we have cos here, we have sine here. So you can use any of the two. Now I'm making use of the second one, which is what? Cos theta equals to sin 90 minus theta. Are you getting it? Now we are asked to solve for the value of theta in this equation. Sin theta equals to cos 40 degree. And from the second identity, cos theta equals to sin 90 minus theta. Now, if cos theta equals to sin 90 minus theta, that means that cos 40 degree equals to sin 90 degree minus 40 degree. Do you get it? So, for this, I'm going to have cos 40 degree equals to sin. Now, 90 degree minus 40 degree, that is what? 50 degree. So, sin 50 degree. Okay? Now, you're going to come back. Please pay attention. You are going to come back to the equation that you are given, which is what? Sin theta equals to cos 40 degree. You are going to replace, instead of cos 40 degree, you are going to replace cos 40 degree as what? Sin 50 degree. Do you get it? So in the equation sin theta, this is the equation that you are solving. Are you getting it? Okay? Equals to, instead of cos 40 degree, you are going to replace cos 40 degree as sin 50 degree. So I'm going to have equals to sin 50 degree. Okay? So we have sin theta equals to sin 50 degree. Okay, so because both trigonometric ratio is the same for both sides of the equation. So theta will be equals to, if you compare, you are going to have theta is equivalent to 50 degrees. Do you understand? If you didn't understand, listen to the explanation again. We have to solve this equation. And I've already told you that for complementary angle, they are angles that are sum up to 90 degrees. Are you getting it? That means that the range of angle that we must be given ranges from 0 degree is less than or equals to theta. Theta is less than or equals to what? 90 degrees. Now, I gave you this identity. All these identities satisfy the following values of theta. Are you getting it? Okay? Sin theta equals to cos 90 minus theta, cos theta equals to sin 90 minus theta, and others. Now, we have to solve this question. In the previous example, I used the first law, but now I'm telling you that you can use the first or the second law. The simple reason is simply because sine is present in the first and cos is also present in the, sine, we have sine of the angle and cos of an angle. In the first and the second identity, we can, sin theta is present, cos theta is present. Likewise, in the second, cos theta is present, sin theta is present. So you can make use of the any of the trigonometric identity. Now, I want to make use of the second one, which is what? Cos theta equals to sin 90 minus theta. Now, in the question that I was given that sin theta equals to cos 40. And from the second trig identity, cos theta equals to sin 90 minus theta. Now, if cos theta equals to sin 90 minus theta, that means that cos 40 degree will be equivalent to sin 90 degree minus 40 degree. Do you understand? Now, having gotten to this point, cos 40 degree equals to sin 50 degree because the difference between 90 and 40 will give me 50. Do you understand? Okay, then I now go back to the first equation that I was given, that sin theta equals to cos 40 degree. Instead of cos 40 degree, I replace it as what? Sin 50 degree. So I have this. Okay, now if you compare both sides, we have sine here, we have sine here. If you compare, that means that theta will be equivalent to what? 50 degree. If you compare both sides. Okay, so the correct answer is what? 50 degree. If you want to make use of the first identity, you can also make use of it for complementary angle. Okay, you can make use of it. Sin theta is what? Cos 90 minus theta. Maybe we should do it. Let's do it together. Okay, I'm coming. If you want to make use of the first law is this: sin theta. Okay, the first law is sin theta equals to cos 90 minus theta. Now, please pay attention. Sin theta equals to cos 90 minus theta. That means that if I want to, I can replace this sin theta as cos 90 minus theta. This is what I'm trying to say. This is the question that we are asked to solve. Sin theta equals to cos 40. We are asked to find the value of theta. Okay? Now, sin theta from the first law, sin theta equals to cos 90 minus theta. So instead of sin theta here, I can replace it as what? Cos 90 minus theta. So I'm going to have cos 90 minus theta equals to what? Cos 40 degree. Do you get it? All I did was that I just replaced the value of sin theta as what? Cos 90 minus theta, because from the first law, sin theta is what? Cos 90 minus theta. So instead of sin theta here, I replace this sin theta as cos 90 minus theta. I've already started the solution using the first law. Now, if you compare both sides of this equation, we have cos, we have cos. Hence, what you have in this bracket must be equivalent to what is present in the front of the cos. Are you getting it? So I'm going to have 90 minus theta. 90 minus theta equals to 40 degree. Okay. Now, to get the value of theta, you just have to take this 90 degree to the other side of the equation. You're going to have negative theta equals to 40 degree minus 90 degree. Okay. Negative theta equals to what? 50 degree. Okay. Oh, negative 50 degree. Then, to get the value of theta, you divide both by what? Negative 1. Okay. So, theta will be equivalent to what? 50 degree. You can see that it's simple. It depends on how you view the question. Okay. It depends on your own perspective of the question. Anytime you are solving a question on complementary angle, the first step is that you have to take note of the trigonometric ratio that is present in both sides of the equation. Are you getting it? So I discovered that sine is present and cos is present. So, and from the complementary angle laws, I know that sin theta equals to cos 90 minus theta, or cos theta equals to sin 90 minus theta. So you can use any of them. Okay. So let's look at one more example. Let's consider the question that we have on the board. We are asked to solve the following equation. Sin 3 theta equals to cos 2 theta. Cos theta plus 10 degree equals to sin theta. Cos x plus 25 degree equals to sin 45. You see, what you are looking for is the variable that is present in the equation. Are you getting what I'm trying to say? The variable that is present in each equation, that is what you are looking for. In this equation, you are looking for theta. Here you are looking for theta. Here you are looking for the value of x. Okay, and we are still going to make use of the complementary angles law. Do you understand? Okay. Now let's start with the first question. Sine 3 theta equals to cos 2 theta. Now, don't forget the law, the steps. The first step is that you have to identify the trigonometric ratio that is present in the equation. In this equation, we have sine and we have cos. So you go back to the complementary angle laws that I gave to you. We have sine theta equals to cos 90 minus theta. And we also have cos theta equals to sine 90 minus theta. So you can make use of any of these two. But I'm going to make use of the first one, which is what? Sine theta equals to cos 90 minus theta. Recall that sine theta equals to cos 90 minus theta. Okay? So, listen. I can replace sine 3 theta as, okay, let's go. Sine 3 theta will be equals to cos 90 minus 3 theta. Do you understand? Okay, this thing is simple. If sine theta equals to cos 90 minus theta, that means that sine 3 theta equals to cos 90 minus 3 theta. It's simple as that, okay? All I did was that if I'm subtracting theta from 90 here, now I have 3 theta. That means that I'm going to subtract 3 theta from 90. Do you understand? Okay, so now from this point, I can replace this sine 3 theta as what? Cos 90 minus 3 theta. Do you get it? So I'm going to have, instead of sine 3 theta, I'm going to have cos 90 minus 3 theta. Cos 90 minus 3 theta equals to cos 2 theta. Do you get it? Okay. Now, comparing both sides, if you compare both sides of the equation, you will discover that I can equate 90 minus 3 theta is equals to 2 theta. Do you know the reason? The reason is simply because I have cos here, I have cos here. And if you compare both sides, so I can set 90 minus 3 theta equals to 2 theta. Okay? We are not done. Okay? Take this 90, take it to the right hand side of the equation. I'm going to have, okay, take this 2 theta, take it to the left hand side of the equation. I'm going to have minus 2 theta minus 3 theta equals to what? Minus 90. The simple reason is because if this positive 90 degree, degree. If this positive 90 degree causes the equals to sign, the sign is going to change to negative, okay? So I'm going to have negative 5 theta equals to negative 90. To get the value of theta, you have to divide both sides by negative 5, okay? So I'm going to have this over negative 5 and this over negative 5, okay? Negative 90 divided by negative 5, that is 18, okay? So the value of theta is equals to 18. Do you understand? Okay, that is the solution to that question. You can see that it's simple. All you have to do is just pay attention. In dealing with complementary angle question, the first step is to identify the trigonometric ratio that is present in the equation that you are given. Having identified that, you have to remember the complementary angles law. Are you getting it? Okay, so between sine and cos, between cos and sine, between cot and tan, between tan and cot, between sec and cosec, and between cosec and sec. Do you understand? Okay, let us look at let's proceed to solve the second example that we have on the board. For the second question, we have cos theta plus 10 degree equals to sine theta. We have to solve for the value of theta. Now, how do we solve for the value of theta? The trigonometric ratio that is present in this equation is what? Cos and sine. So let's go back to this. Sine theta equals to cos 90 minus theta and cos theta equals to sine 90 minus theta is what we are going to use, okay, to solve for the value of theta. So let us make use of sine theta equals to cos 90 minus theta. Sine theta equals to cos 90 minus theta, okay. Now, because I have sine theta here, I'm going to replace this sine theta as what? Cos 90 minus theta. So the equation becomes cos theta plus 10 degree equals to what? Instead of sine theta, I'm going to replace sine theta as cos 90 minus theta. Okay, so for this I'm going to have cos 90 minus theta. Now, having gotten to this point, you can now set the bracket equals to each other. Like, because I have cos here, I have cos here. If I compare both sides, I can set theta plus 10 degree is equivalent to what? 90 minus theta degree. Okay, so I'm going to have theta plus 10 degree equals to what? 90 minus theta. Okay, 90 degree minus theta. Now, the next step is to collect like terms. Do you get it? Okay, I'm going to bring this negative theta to the left hand side of the equation. Hence, the negative sign is going to change to positive sign. So I'm going to have theta plus theta equals to what? 90 degree. Now, if this positive 10 degree crosses the equals to sign, the sign is going to change to a negative sign. So I'm going to have minus 10 degree. 2 theta equals to 80. To get the value of theta, divide by 2. Theta equals to what? 40 degree. Okay, so you can see that the solution is quite simple. If you understand the basic step, you'll be able to solve any question that comes under complementary angle in your exams. Okay, so let's look at the third example. Cos x plus 25 degree equals to sine 45 degree. How do we solve for the value of x? Now listen to me carefully. Don't be surprised by the variable that you have. Okay, they can represent the angle that they want you to find as any letter, or even theta, or alpha, or lambda. It doesn't matter. Okay, so all you yours is just to calculate the angle. Are you getting it? Now for this for instance, this one we are looking for the value of x. You can see that they didn't give us theta. Okay, we are not looking for theta here, we are looking for the value of x. So they can represent the angle that they want you to find as any letter or anything. Just make sure that you get the concept and solve the angle. Now, how do we get the value of x in this equation? Now, what trigonometric ratio is present in this equation? It is cos and sine. And in complementary angle, the relationship that exists between cos and sine is this. Sine theta equals to what? Cos 90 minus theta, or cos theta is what? Sine 90 minus theta. Likewise, I can replace theta as x. Sine x equals to cos 90 minus x. Why? Cos x equals to sine 90 minus x. Do you understand? Theta is just the representation. It's just a representation of the angle. Now, because the angle changes to x, they give us the angles as x. So we can say that cos x equals to what? Sine 90 minus x. So we can use this. If cos x equals to sine 90 minus x, I can replace, listen to me, you can use the first or the second. Now, looking at this now, looking at the identity that I wrote here, I'm using the second, right? Yes. You can use any of it. Just know, you see, when you get the basic concept, no matter how twisted the question is, you will be able to solve it. Do you get it? Okay? Now, I'm using the second identity. Cos x equals to sine 90 minus x. That means that cos x plus 25, listen, cos x plus 25, cos x plus 25 degree will be equivalent to what? Sine 90 minus x plus 25 degree. I'm going to explain, just pay attention. Listen, please listen to me. Listen, cos x equals to what? Sine 90 minus x. Now, cos x plus 25 degree will be what? Sine 90 minus x plus 25 degree. Are you getting it? So, I can simplify the right hand side. Cos x plus 25 degree equals to sine 90, oh yeah, open the bracket, minus times x, minus x, minus x, then minus times plus 25 degree. That is what? Minus 25 degree. Okay? So cos x plus 25 degree is equals to sine, now 90 minus 25 degree. That is what? 65 degree. Do you get it? So I'm going to have 65 degree minus x. So I have simplified I have simplified this to 65 degree minus x. Now the next step is that you have to go back to the equation that you are given. Now, since cos x plus 25 degree is equivalent to sine 65 degree minus x, so instead of writing cos x plus 25 degree here, I'm going to replace it as what? Sine 65 degree minus x. Do you get it? So let us proceed. Sine 65 degree minus x equals to sine 45 degree. Sine 45 degree. Do you know what I did? Instead of writing cos x plus 25 degree, I replaced it as what? Sine 65 degree minus x. This is the equation that we are solving. Do you know? Cos x plus 25 degree equals to sine 45 degree. Now, I express cos x plus 25 degree as what? Sine 65 degree minus x. So, instead of writing this in this place, I just replace what I have here as this. Do you get it? Okay? So, now, if you compare both sides, listen. If you compare both sides, we have sine here, we have sine here. So, I can equate 65 degree minus x equals to what? 45 degrees. So, I'm going to have 65 degree minus x equals to what? 45 degree. Hence, collect like terms, I'm going to have minus x equals to what? 45 degree minus 65 degree. Because if this 65 degree crosses the equals to sign, the positive sign is going to change to a negative sign. Do you get it? Okay, having gotten to this point, 45 degree minus 65 degree minus 20 degree. Okay, to get the value of x, divide both by what? Negative 1. Okay, so I'm going to have this over negative 1, this over negative 1. The value of x is equals to 20. X is equals to 20 degree. You can see that it's simple. Now let us verify. You can check your answer using calculator. Okay, you can check your answer if the answer that you get is correct or not. Now, if x is 20 degree, let us substitute the value of x into this equation. This is the equation that we are asked to solve. Okay. Now let us substitute the value of x as 20 degree into this equation. When x is 20, I'm going to have in the left hand side now, I have cos x plus 25 degree. When x is 20 degree, I'm going to have cos 45 degree, right? Yes. And at the right hand side, I'm having sine 45 degree. Cos 45 degree is equals to sine 45 degree. Okay? Cos 45 degree is 0.7071 or 1 over root 2. And sine 45 degree is also what? 0.7071 or 1 over root 2. Or root 2 over 2 also. You can do it. Are you getting it? So that is it. I'm very sure if you come across this kind of question in the exam now, you'll be able to solve it. It's simple. Okay, let's consider the following question on complementary angle. We are asked to solve the following equation. If sine 20 degree equals to cos y, find y. Okay, let's start with the first question. Sine 20 degree equals to cos y. Now, don't forget that in the trigonometry identity that I wrote on the board, sine theta equals to cos 90 minus y. That means that sine y will be equals to cos 90 minus y. Do you understand? Okay, here theta is the angle that we are looking for, and in this case, y is the angle that we are looking for. So in that case, I can replace this sine 20 degree. Listen to me carefully. If sine y equals to cos 90 minus y, that means that sine 20 degree equals to what? Cos 90 degree minus 20. Do you get it? Hence, sine 20 degree equals to what? Cos 70 degree. Okay? Now, sine 20 degree is equivalent to cos 70 degree. So, instead of sine 20 degree that I have here, I can replace this one as cos 70 degree. Okay? So, I'm going to have cos 70 degree equals to cos 70 degree equals to cos y. Okay, if you compare both sides, listen to me carefully. If you compare both sides, cos 70 degree is equals to cos y. That means that y is equivalent to 70 degree. Okay, because we have cos here and we also have cos here. So if you compare both sides, that means that y is equals to 70 degree. Okay, that is the value of y. And don't forget that I told you that complementary angle are angle that are sum up to what? 90 degree. Okay, now let us check if these angles are sum up to 90 degree. We have sine 20 degree. If you have 20 degree with 70 degree, you are going to have 90. You get it? So the value of y that will make these angles complementary is 70 degree. Do you get it? Okay. Look at the second question. Given that cos 70 degree equals to sine x, what is the value of x? We are still going to go the same way. Don't forget that in the second identity, we have cos theta equals to what? Sine 90 minus theta. Hence, okay, let me rub this. Let me rub this off. From the second identity, cos theta equals to sine 90 minus sine 90 minus theta. So for this, cos 70 degree will be equals to sine. Okay, this is the question. Cos 70 degree equals to sine 90 minus 70 degree. Okay, so cos 70 degree equals to sine 90 minus 70 degree is 20. So I'm going to have equals to sine 20 degree. Okay, so you can go back to the initial equation that you are given. This is the question that we are solving. Do you know? Now I have simplified cos 70 degree as sine 20 degree. So I can replace cos 70 degree as sine 20 degree. So I'm going to have sine 20 degree equals to sine x. You get it? Now sine 20 degree equals to sine x. If you compare both sides, the x will be equivalent to what? 20 degree. If you compare both sides, because we have sine here, we also have sine here. The degree, the angles in the front of sine in this place is what? 20 degree. While we have x as the angle in the front of this sine x and in the front of this sine. Hence, the value of x is 20 degree. So here I'm going to have 20 degree. So to check whether your answer is correct, since we are dealing with complementary angle, the summation of the 70 degree and the value of x must be equivalent to 90 degrees. So if you sum 70 degree, and we have already gotten x as was 20 degree, if you sum 20 degree and 70 degree together, you're going to have 90 degree. So the value of x that will make this these angles complementary is 20 degree. Do you understand? Okay, let's proceed to this third question. For the third question, we have solve for x if sine x equals to cos 40 degree. Solve for x sine x equals to cos 40 degree. We are asked to find the value of x. Now don't forget that sine theta equals to cos 90 minus theta. So let us use that identity. Sine theta equals to cos 90 minus theta, right? That means that sine x will be equal to what? Cos 90 minus x. Do you know? Now, if sine x equals to cos 90 minus x, we can replace the value of sine x as cos 90 minus x in the initial equation that we are asked to solve. So for this, I'm going to have cos 90 minus x equals to what? Cos 40 degree. Okay. Now, if you compare both sides, the angle at the front of cos in this place is what? 40 degree. And at the front of the cosine that I have here is what? 90 minus x. So let us equate 90 minus x and 40 degree. So I'm going to have 90 minus x equals to 40 degree. Okay. The next step is to take this 90 degree to the right hand side of the equation. So I'm going to have negative x is equals to 40 degree minus 90 degree. Okay. For this, we are going to have negative x is equals to 40 degree minus 90 degree. That is what? Negative 50 degree. Okay. Divide this by negative 1, this over negative 1, and this over negative 1. X will be equals to what? 50 degree. So the value of x that will make this angle complementary is 50. Let us check. X is 50, so I'm going to have sine 50 equals to cos 40, right? If you sum 40 and 50 together, you're going to have 90. Do you get it? So the value of x is 50 degree, and you can punch your calculator. You can check in your calculator. If you punch sine 50 degree, sine 50 will give you 0.7660. If you press cos 40 degree, you are still going to have 0.7660. You understand? So that is the value of x that makes the angles complementary. Let us check for question 4. We are asked to find the value of x if sine 3x equals to cos 2x. You can try that, then when you are done, you play the video to check whether you are correct. Okay. Solution. For the first one, okay, for the fourth one, we have sine 3x equals to cos 2x. Now we are asked to find the value of x. don't forget that from this identity, you see, you can use any of this identity. You can use either the first or the second, okay? It depends on you. Now, let us use the first one. The first one says that sine theta equals to what? Cos 90 minus theta. So sine x equals to what? Cos 90 minus x. Okay, what was sine 3x? Sine 3x will be equals to what? Cos 90 minus 3x. Okay, now the next step is that you have to replace the value of sine 3x as cos 90 minus 3x. Do you get it? So for this, I'm going to have cos 90 minus 3x is equals to cos 2x. Now, if you compare the left hand side and the right hand side, we can equate 90 minus 3x and 2x. Do you get it? So I'm going to have 90 minus 3x equals to 2x. Now, the next step is that you have to take this 2x to the left hand side of the equation. So I'm going to have minus 3x. Listen to me carefully. You know that the goal is to find the value of x, right? Now, to get the value of x, you have to collect like terms. And by doing that, you have to take this 2x to the left hand side of the equation. So because 2x is positive at the right hand side, you're going to have a negative sign. So I'm going to have minus 2x minus 3x equals to 90. You get it? Minus 2x minus 3x, that is minus 5x. Minus 5x equals to 90. Okay? If this 90 crosses the equals to sign, the positive sign is going to change to negative. Do you get it? So that's why I have negative 90 at this point. Okay, to get the value of x, what are you going to do? Divide both sides by negative 5. So for this, I'm going to have this over negative 5, this over negative 5. X is equals to 18. X is equals to 18. So that is the solution to that question. For question 5, we have sine x equals to cos 60 degree. To get the value of x, all you have to do is that just subtract 60 from 90 degree. That will be the value of x, okay? That means that the value of x that will make these angles complementary is 30 degrees. Are you getting it? Because 90 minus 60 will give me 30. Okay, so that is the solution on cos and sine. The relationship that exists between cos and sine of a complementary angle is this: sine theta, sine angle, sine of the angle that you are given is equivalent to cos 90 minus the angle that you are given. Okay, so if you want to find the complementary angle of sine 40 degree, what will be? That will be what? Cos 50 degree. And the complementary angle of sine 70 degree will be what? Cos 20 degree. Do you understand? Just subtract 90 from the angle that you are given to get it complementary. Okay, so that is the solution of cos and sine of an angle. Now let's look at the cot and tan. Cot, you see, the cot that you have here means cotangent. We have already learned inverse trigonometric ratio. Cotangent simply means the inverse of tan. Are you getting it? And we have tan theta. So the cot of the angle that you are given is equals to tan 90 minus the angle that you are given. Let's also look at work example on that as well. Solve the following equation. We have tan 45 degree equals to cot y. How do we find the value of y in this equation? Solution. Tan 45 degree equals to cot y. Please pay attention. Don't forget that the cot of the angle that we're looking for is equals to tan 90 minus the angle that you are given. Listen to me carefully. Cot theta is just the angle that you are given. Are you getting what I'm saying? Theta is the angle that you are given, and the cotangent of the angle that you are given is equals to tan 90 minus the angle that you are given. Now listen, we have tan 45 degree is equals to what? Cot y. We are asked to find the value of y. The second identity that is related to this one is what? Tan theta. Tan theta equals to cot 90 minus theta, right? Now, tan y will be equals to what? Cot 90 minus y. Do you get it? If tan theta equals to cot 90 minus theta, that means that tan y will be equals to cot 90 minus y, okay? Because I told you that theta can be anything. It can be any letter. It can be any symbols, okay? The goal is just to understand the relationship that exists between the trigonometric identity that you are looking for, okay? And I told you that for complementary angle, tan theta equals to cot 90 minus theta, okay? So now, when you recall that tan y equals to this, we can replace tan y equals to cot 90 minus y. That means that cot y will be equals to tan 90 minus y. Do you understand? Okay, from this point we can replace cot y as tan 90 minus y. Do you understand? So I'm going to have tan 45 degree is equals to tan 90 minus y. Do you know what I did? I just replaced cot y as tan 90 minus y. Now, if you compare both sides of the equation, we can equate 45 degree and 90 minus y. Okay, so I'm going to have 45 degree is equals to 90 minus y. Okay, the goal now is to find the value of y. How do you get the value of y? Just take this y to the left hand side of the equation. I'm going to have y is equals to 90. Now, if this 45 causes the equals to sign, the positive sign is going to change to negative. So I'm going to have minus 45 degree. So the value of y equals to 45 degree. Now, I told you complementary angle are sum up to 90 degree. So if y is 45 degree, if you sum 45 degree and 45 degree, you're going to have 90. So the solution to this question is 45 degree. Do you understand? Okay, let's look at the second question. You're asked to solve for the value of x. Cot 30 degree equals to tan x. Well, to get the value of x, it's simple. Since you know that cot theta equals to tan 90 minus theta. Okay, let's go. Cot 30 degree equals to tan x. We are asked to find the value of x. X is an angle. We are asked to find the angle that is that belongs to x. We are looking for the value of x. Cot 30 degree equals to tan x. How do we solve for the value of x? The first step is that you have to go back to the trigonometric identity that you are given. Cot theta equals to tan 90 minus theta. Hence, please pay attention. Hence, if cot theta equals to tan 90 minus theta, cot x will be equals to what? Tan 90 minus x. Abi? Also, tan x will be equals to cot 90 minus x, right? Now, because tan x is here, tan x is equals to cot 90 minus x. That means that I can replace tan x as what? Cot 90 minus x here. So I'm going to have cot 30 degree is equals to cot 90 minus x. Now, to get the value of x, we can compare both sides because we have cotangent here and we have cotangent here. I can set 30 degree equals to 90 minus x. So in that case, I'm going to have 30 degree equals to 90 minus x. To get the value of x, collect like terms, okay? I'm going to have minus x is equals to 30 degree minus 90. What do I do? I just take this negative, this 90 to the left hand side of the equation and I make use of transposition. If you understand, let me explain. This is what I did. 90 minus x equals to 30 degree. Transposition. I just changed the position of this and this. Okay? I've not done anything. So now this, I'm going to have minus x equals to 30 degree minus 90 degree. Okay? Do you get it? Now, minus x equals to what? 60 degree. Because 30 degree minus 90 degree will give us minus 60 degrees. So, to get the value of x, you divide this by minus 1. Minus 1, minus 1. X is equals to 60 degree. Okay? To check whether your answer is correct, the summation of this angle and the value of x must be equivalent to 90 degree. Hence, if you want to check, just sum 30 degree and 60 degree. If it doesn't give you 90 degree, that means that your solution is wrong because now theta ranges between 0 degree and 90 degree. It must be their sum must be equal. Are you getting it? If you sum them together, you must have 90 degree. If you didn't have 90 degree, that means that your solution is wrong. Do you understand? Okay? You can try the rest of the question. Solve for the value of x in tan 2x equals to cot x. And solve for the value of y in tan 3y equals to cot 2y. It's simple. When you are done, you can send your solution to me and you can drop it in the comment section. Let's consider the following question on the board. You know, we've talked about sin theta and cos theta. We have talked about cot theta and tan theta. Now we are looking at the relationship that exists between sec theta and cosec theta for complementary angle. Okay? Don't forget that I told you that complementary angle are sum up to what? 90 degree. Okay? So for the first question we have sec theta sec theta, okay, sec theta, okay, sec 30, sorry, sec 30. Sec means secant, okay, sec 30 degree equals to cosec y. You see, the meaning of CSC is cosec. Do you understand? Okay, the meaning of CSC is cosec. Do you get it? So sec means secant, while CSC means cosec, and cosec is what? Cosecant. Okay, now we are asked to find the value of y in this identity. Now, what value of y will make, what values of y can we sum to 30 degree that will make it equivalent to 90 degree? That is what we are asked to do. Okay, now let us solve it. Don't forget that I told you sec theta equals to what? Cosec 90 minus theta. Are you getting it? So that means that sec 30, listen, sec 30 degree can be written as what? Cosec 90 minus 30. Do you understand? Okay, sec 30 is equals to cosec 90 minus 30, because from this identity I told you sec theta is what? Cosec 90 minus theta. Now theta is now 30 degree, and if theta is 30 degree, that means that the cosec of the complementary angle that we the angle that will complement sec 30 degree will be what? Cosec 90 minus 30. Do you get it? So let us proceed. For this, I'm going to have sec 30 degree is equals to cosec 60 degree. Do you know? Now I will go back to the equation that I was given. Sec 30 degree is equals to cosec y, and from this identity sec 30 degree is equals to cosec 60 degree. So therefore I'm going to replace sec 30 degree as cosec 60 degree. Okay, so sec 30 degree is equals to the cosec of y, CSC, sorry, CSC. Okay, please pay attention. That means that since sec 30 degree is equals to cosec 60 degree, from this point I'm going to have, instead of sec 30 degree, I'm going to replace that cosec. So cosec 60 degree is equals to cosec y. Okay, now if you compare both sides, you will discover that we have cosec here, we have cosec at this point, and we have cosec here. That means that the angles at the front of cosec must be equal. Are you getting it? And if you compare, you are going to discover that y is equivalent to 60 degree. Do you understand? Y equals to 60 degree. You see, these questions are very simple. All you have to do is that just master this identity. Okay, let's proceed to question 2. We have cosec y is equals to sec 20 degree. Now, how do we solve for the value of y in this equation? This is C. Cosec y is equals to sec 20 degree. How do we solve for the value of y? Okay, don't forget that sec theta is equals to what? Cosec theta is equals to sec 90 minus theta. That means that cosec y, listen, cosec y is equals to sec 90 minus y. Do you know? Like what I have here, cosec theta is equals to sec 90 minus theta. That means that cosec y is equals to sec 90 minus y. Are you getting it? Now, I will now go back to this equation. I will replace, instead of having cosec y here, I'm going to replace it as sec 90 minus y. Are you getting it? So, in that case, I'm going to have sec 90 minus y is equals to sec 20. Do you understand? Now, because I have the same trig ratio, I have the same trigonometric ratio at the left hand side and the right hand side, I can equate the angles that is before them. Are you getting it? The angle before this sec is what? 90 minus y, and the angle before the sec at the right hand side is what? 20. So let us equate them together. I'm going to have 90 minus y is equals to 20. Do you get it? Okay. Now take this 90 to the other side of the equation. You're going to have negative y is equals to 20 minus y. Okay. Negative y is equals to, oh, sorry, it is 90 that we brought. Okay. So I'm going to have negative 90. Okay, 20 minus 90 is negative 70. Okay, to get the value of y, divide by minus 1. So the value of y is equals to 70. Do you understand? So, and if you want to check your answer, you can check. Just add 70 and 20. It must be equals to 90. If the angle is not sum up to 90, that means that something is wrong with your calculation. Okay, you have to check. Are you getting it? So you can see, you can always press this. Hello. If you check this in your calculator, cosec y simply means cosec y, cosec y, cosec y is equals to what? 1 over cos y. Do you understand? Oh, 1 over sine y, sorry. 1 over sine y. And sec 20 degree, I'm just introducing you to another concept now. Sec 20 degree is equals to 1 over sine, 1 over cos 20 degree. Don't forget that I taught you inverse trigonometric ratio. Okay? So if you want to check this in your calculator, since y equals to 70, that will be what? 1 over sine 70 degree. 1 over sine 70 degree. If you press 1 over sine 70 degree in your calculator, and if you press 1 over cos 20 degree in your calculator, you're going to have the same answer. Do you understand? Let's check. 1 divided by sine 70 degree. That will give us 1.064. 1.064. What of 1 over cos 20 degree? 1 divided by cos 20 degree. That is also 1.064. Do you understand? So you are going to have the same answer. So please master this identity. Do you understand? It's going to help you in your exams. Are you getting it? Master it very well. Now, that is the solution to the second question. Let's proceed to the third question. You can try the third question by yourself. And then, when you are done, you can check whether you're correct or wrong. Okay, the third question, we have cosec x is equals to sec 75 degree. We are asked to find the value of x. Okay, now don't forget that from these identities, cosec theta is what? Sec 90 minus theta. That means that cosec x can be written as sec 90 minus x. Do you understand? Okay, now having gotten to this point, I'm going to go back to the initial equation and replace cosec x as sec 90 minus x. So I'm going to have sec 90 minus x is equals to sec 75 degree. Do you understand? Okay, now because we have the same trigonometric ratio at the left and the right hand side, which is sec and sec, we can equate their angles. The angles that is before each trigonometric ratio, which is 90 minus x and 75. So I'm going to have 90 minus x is equals to 75 degree. Okay, to get the value of x, just take this 90 to the other side of the equation. If it crosses the equals to sign, we are going to have a negative 90. So I'm going to have minus x equals to 75 degree minus 90 degree. And you can subtract 90 from both sides. You're going to have something like this as well. Okay, you can subtract 90 from both sides or take this 90 to the other side of the equation, depending on how you understand, how you got the question. Okay, so for this I'm going to have minus x is equals to 75 degree minus 90 degree. What's the answer? That is 15, right? So I'm going to have minus 15 degree. To get the value of x, the value of minus 1. The goal is to find the value of x. We are not looking for the value of minus x. That is why we have to eliminate the minus sign by dividing both sides by negative 1 or multiplying both sides by negative 1. Okay, so for this I'm going to have x is equals to 15 degree. To check our answer, let us check. To check our answer, if you have 75 degree and 15 degree, if it doesn't give us 90 degree, that means our answer is wrong. But if you add 75 degree plus 15 degree, you're going to have 90. Okay, so that is the solution to the third question. Okay, let's proceed to the next question, which is question 4. The reason why I'm solving more question on this is simply because if you practice consistently, before you know it, you'll be able to master everything that you have here. Okay, so let's look at the fourth question. We have cosec 2 theta. Cosec 2 theta. Cosec 2 theta is equals to sec 3 theta. We are asked to find the value of theta. Okay, now how do you get the value of theta? Please, I want you to pay attention. Now, don't forget that cosec theta is equals to what? Sec 90 minus theta. Cosec theta is equals to sec 90 minus theta. That means that cosec 2 theta will be equals to what? Sec 90 minus 2 theta. Do you understand? No matter the numbers of angle, please pay attention. No matter what you have on at the front of cosec that are given in the question, just subtract 90 from it. You're going to have the angle in secant. Are you getting it? So we know that cosec theta is equals to sec 90 minus theta. And now we are given cosec 2 theta. Cosec 2 theta will be equals to sec 90 minus 2 theta. Do you understand? Okay, that's the first step. Now, Having gotten to this point, go back to the equation that you are given. Replace cosec 2 theta as sec 90 minus 2 theta. So I'm going to have cosec, instead of cosec 2 theta, listen, instead of cosec 2 theta here, I'm going to replace that sec 90 minus theta. So I'm going to have sec 90 minus 2 theta, is equals to sec 3 theta. Do you understand? Because what we have here is sec 3 theta. Are you getting it? So what I did was that I just replaced this cosec 3 theta as sec 90 minus 2 theta. Do you get it? Now we can equate their angle. Are you getting it? Because we have cosec here, we also have cosec here. We can equate the angle that we have at the front of this sec. Like we have sec here, we also have sec here. We can equate the angle that we have at the front of this sec. So I'm going to have 90 minus 2 theta. 90 minus 2 theta is equals to 3 theta. Okay? To get the value of theta, all you have to do is that just collect like terms. Okay? I'm going to have minus 2 theta minus 3 theta is equals to minus 90. Okay? So I'm going to have minus 5 theta is equals to minus 90. Do you understand? Now, having gotten to this point, the next step is that you have to divide both sides by minus 5. Do you understand? So, if you divide, please pay attention. If you divide this by minus 5, you're going to have theta, and this by minus 5, you're going to have 18. So I'm going to have theta is equals to 18 degree. Do you understand? Okay, let us check. Let us substitute the value of theta as 18 in this equation. In cosec 2 theta, theta is 18. 2 times 18 is what? 36, right? So I'm going to have cosec 36. Cosec 36 is equals to, now, okay, for sec 3 theta, when theta is 18, I'm going to have 3 times 18, that is what? 54. So I'm going to have sec 54, right? Now, if you have 54 and 36, you're going to have 90, which implies that we are correct. Do you understand? Okay, so you can attempt the fifth question, which is sec theta plus 40 degree equals to cosec theta. You are asked to find the value of theta. I'm very sure you can do that. You can attempt that one, then when you are done, you can play the video to check whether you are correct. Okay, now look at this. Look at this. Sec theta plus 40 degree is equals to cosec theta. Let's shorten it, CSC. Now, we are asked to find the value of theta. Now, don't forget that in this place, sec theta is what? Cosec 90 minus theta. So, that means that if sec theta is equals to cosec 90 minus theta, that means that sec theta plus 40 degree is equals to cosec 90 minus theta plus 40 degree. Do you understand? Okay, so let's go. For this, I'm going to have sec theta plus 40 degree will be equals to cosec 90 minus, okay, are you there? 90 minus theta plus 40 degree. Do you understand? Do you understand what I did? If sec theta is equals to cosec 90 minus theta, that means that sec theta plus 40 degree will be equals to cosec 90 minus theta plus 40 degree. Do you understand? Okay. Now, having gotten to this point, you can just simplify. Let's simplify, okay? Let's simplify. For this, I'm going to have sec, before we proceed, let's simplify. Sec theta plus 40 degree will be equals to cosec, now, 90 minus theta minus 90 minus theta, because this negative sign will affect every entity that is present inside the bracket. So I'm going to have negative theta, negative 40 degree. Okay? Negative 40 degree, okay? Now, for this, I'm going to have sec theta plus 40 degree is equals to cosec 90 minus 40 degree, that is what, 50, right? So I'm going to have cosec 50 degree, 50 degree minus theta, okay? Now, we have already simplified what we have inside the bracket, okay? From that point, we can go back to the initial equation and replace sec theta plus 40 degree as cosec 50 degree minus theta. The reason is simply because, don't forget that from this identity, we have that sec theta plus 40 degree is equals to this. Now we can go back to the initial equation and substitute the value of sec theta plus 40 degree as cosec 50 degree minus theta. So I'm going to have cosec 50 degree minus theta is equals to cosec theta. Do you get it? Okay. From this point, the next step is to equate the value of 50 degree minus theta and theta. Because we have cosec here, we have cosec here. We can equate 50 degree minus theta and theta. So I'm going to have 50 degree minus theta equals to theta. Do you get it? Now, the next step is that you have to take this theta to the left hand side and bring this 50 degree to the right hand side of the equation. So I'm going to have theta minus theta is equals to minus 50 degree. Do you get it? Okay, minus theta will give us minus 2 theta. So for this, I'm going to have minus 2 theta is equals to minus 50 degree. To get the value of theta, divide both sides by what? Negative 2. I'm going to have negative 2. Okay, so theta is equals to 25 degree. Do you understand? Okay, the value of theta for this for the fifth question is 25 degree. Do you understand? Okay, let's try. Maybe let's check. For adventure, we made a mistake, or we want to verify maybe we are correct. Don't forget that we are dealing with complementary angle, and complementary angle must be summed up to 90 degree. Okay, when theta is 25 degree, 25 degree plus 40 degree, that is what, 65 degree, right? Yes. And what of sec theta? We have theta here. That means that I'm going to have theta as 25 degree here. 25 degree plus 65 degree, what will be the answer? That is 90, okay? Which implies that the value of theta that we have as 25 degree is correct. Do you understand? Okay, so that is the solution to that question. If you want more questions on trigonometric identity, you can check the link in the description of this video, okay? Especially on complementary angle, okay? Check the link in the description of this video. Okay, let's talk about special angle. Special angles are those angles in trigonometry that have well-known and exact value for sine, cosine, and tangent. Are you getting it? So these angles, they have an exact value. So let's look at the table that we have on the board. We have 0 degree, it is part of the special angle, 30 degree, 45 degree, 60 degree, and 90 degree. Okay, we are asked to determine the sine, the cosine, the tangent, the cosec, sec, and cotangent. You understand? You see, listen to me. If you are able to get sine, cos, and tan, you know that all these three, the remaining three are just the inverse of sine, cos, and tan respectively. Do you understand? So let's focus on sine, cos, and tan. If you know sine, cos, and tangent of these angles, we can easily determine the cosec, the sec, and the cotangent of the angles. Are you getting it? So to determine the values of all these special angles, I'm going to teach you two ways. Are you getting it? The first way is that I'm going to use your hands. You can make use of your hands, okay? And you can just draw out the structure of hands. Hello? Just draw out something like this. Are you getting it? You can make use of your hands. Oh, this one's supposed to be 5. Sorry. We're supposed to have 5. So we have one more. Are you getting it? Hey, your hands have 5 fingers. You get it? So we have 1, 2, 3, 4, 5. Are you getting it? Now label this. Label the hands 0 degree, 30 degree, 45. Sorry, 45 degree, and 60 degree, and then 90 degree. According to what we have here: 0 degree, 30 degree, 45 degree, 60 degree, and 90 degree. Are you getting it? Okay. Now, listen to me carefully. The sine of any angle among these special angle that we have here, the sine is equivalent to, please pay attention, the sine is equals to the square root of finger below all over 2. Please, just pay attention, okay? You're going to understand what I'm doing. Just pay attention. Listen to me carefully. To get the sine of any special angle, you can make use of this formula, the square root of finger that you have below all over 2. Okay. Now the cos of any angle where theta is either 0 degree, 30 degree, 45 degree, 60 degree, or 90 degree. You understand? Theta is one of the special angle. Are you getting it? So the cos theta is equal to square root of finger above square root of finger above all over 2. Are you getting it? Okay. Now, for tan theta, tan theta is equals to the square root of finger below all over the square root of finger above. Okay, that is the tan of any special angle with respect to our finger. You know, we are using our finger now. Are you getting it? So I just draw out the finger to help you to understand what I'm doing. Okay, so tan theta, tan of any special angle is equals to the square root of finger below all over the square root of finger above. Okay, now having understand this formula, let us look at what we have on the board. Let's say theta is now 0. Are you getting it? You know, I told you 0 is also part of the special angle that we are considering. Are you getting it? So let's say theta is now 0. Are you getting it? Now look at 0. This is where 0 is. This is where 0 is, right? Now sine theta, which is what? Sine 0. Let's go. Sine 0 degree. When theta is 0, sine 0 degree is equals to the square root of finger below all over 2. Now listen to me carefully. How many fingers do we have below 0? Listen, this is your finger. How many fingers do we have below this finger? There is no finger. Are you getting it? That means 0. Are you getting it? We are having 0 finger below this finger. So I'm going to have the square root of 0, all over 2, which is what? 0 over 2, which is 0. Do you understand? Let me explain again. Just pay attention. You know, when I start this class, I told you that there are 2 ways to get special angle. You can master the special angle in 2 ways. Are you getting it? But this is just the first method, which is your finger. Are you getting it? Just imagine this as your finger. Are you there? Now, below this finger, there is no finger below it. Are you getting it? I told you that the sine of any special angle is equals to the root of finger below all over 2, right? Now, from your finger, there is no finger below this finger. Are you getting it? And if you check the diagram that I have on the board, this is where I put 0 degree. And there is no finger below this finger. That means that the finger below this finger is 0. Are you getting it? Because we didn't have any finger that is below it. Are you getting it? So sine of any special angle is equals to the root of finger below all over 2. That means what? Root of 0 all over 2. Are you getting it? And if you take the square root of 0, you're going to have 0 over 2, which will give you 0. Do you understand? So the sine 0 degree is 0. Do you understand? Okay, let us look at sine 30 degree. Okay, wait. Let's focus on 0 degree only. Let's first deal with 0 degree. Let's start with cos. Are you getting it? Let's continue with cos. For the cos, I'm going to have cos 0. Please pay attention. Cos 0 degree is equals to root of finger above, right? Because the cos of any special angle is equals to the root of finger above all over 2. Now, how many fingers do we have above this finger? You know, this finger that you see here belongs to 0. Are you getting it? Now, how many fingers do we have above 0? We have 1, 2, 3, 4. So we have 4 fingers. And the cos of any angle, cos of any special angle is equals to root of finger above all over 2. Now, cos 0 degree will be what? Root of finger that is above the finger that belongs to 0 all over 2. How many finger is above the finger that belongs to 0? That is 1, 2, 3, 4. So I'm going to have root of 4 all over 2. That will be what? 2 all over 2, which is what? 1. Do you understand? Okay. So cos 0 will be 1. Are you getting it? Now, let's look at tan 0. Tan 0. What will be the value of tan 0? I want to check. From what I wrote on the board, what will be the value of tan 0? Tan 0 degree will be equals to root of finger below all over root of finger above. Okay? How many fingers do we have below 0? There is no finger. This finger belongs to 0, right? How many fingers do we have below this finger? There is no finger. So I'm going to have root of 0 all over root of finger above. How many fingers do we have above this finger? That is 1, 2, 3, 4. So I'm going to have all over root of 4. That's what? 0 all over 4. Okay? 0 divided by 4 will give us what? 0. Do you understand? So the answer is 0. Okay? So for this, I'm going to have 0 in this place. Okay? Now, what of cosec? Cosec 0. Listen to me carefully. I told you that the cosec simply means cosecant, right? And cosecant simply means the inverse of sine. Are you getting it? When you take the inverse of sine of an angle, what you have is cosecant. Okay? So, what will be the cosecant of 0? Cosec 0. let us shorten it for the sake of space. CSC. Okay, cosec 0. Cosec 0 degree. What will be the value of cosec 0 degree? Okay, that will be what? 1 over 0 degree. Are you getting it? Cosec 0 is what? 1 over, please pay attention, 1 over sine theta. And sine 0 is what? Cosec 0 is 1 over sine 0 degree. And sine 0 degree is what? 0. So I'm going to have 1 over sine 0. 1 over sine 0 is undefined. So we're going to put it as infinity. Do you understand? We're going to represent it as this. We're going to represent it as this symbol, infinity. Infinity. Okay? Because 1 over 0. 1 over 0 is an undefined fraction. 1 over sine 0. Sine 0 is 0. So if you take the inverse of sine of 0 degree, you're going to have 1 over 0. And 1 over 0 is undefined. You understand? 1 over 0 is undefined. And because it is undefined, we're going to represent it as infinite, infinity. This symbol that you see here is called infinity. Do you understand? Okay? Let's look at sec 0. The secant, please pay attention. Sec 0 degree. Okay? Sec 0 simply means the inverse of cosine. Are you getting it? Okay? Cosine is what? 0. Cos 0 is what? 1. So secant will be what? 1 over cos 0. And cos 0 is what? 1. So I'm going to have 1 over 1. 1 over 1. 1 over 1 will be equals to 1. Do you understand? So the value that I'm going to have here now is 1. Please, let me reiterate. It's simple. I taught you inverse trigonometric ratio. The inverse of sine is cosecant. Now we are dealing with special angle. Cosec 0 is the inverse of sine. Are you getting it? Inverse of sine 0 will give us cosec 0. And sine 0 is what? 0 degree. Sine 0 degree is what? 0. Are you getting it? Now, if sine 0 is 0, 1 over sine 0 will be what? 1 over 0 degree. Are you getting it? 1 over 0. And 1 over 0 is undefined. Are you getting it? So I have the values as infinity. Infinity. Do you understand? Okay, it's simple. And for secant is the inverse of cos. And cos 0 is what? 1. 1 over 1 will give me what? 1. That's why I have 1. Do you understand? Okay, what of cotangent? Cotangent is the inverse of tan. That means that if I want to find cot 0 degree, cot 0 degree will be equals to 1 over tan 0 degree. And 1 over tan 0 degree is what? 1 over 0, because tan 0 is what? 0. Tan 0 is what? 0. Tan 0 degree is what? 0. Do you understand? I'm emphasizing on it because you're going to make use of this in. You are still going to we are still going to solve for 30 degree, 45 degree, 60 degree, and 90 degree. So if you can master sine, cos, and tan, you are done with the table. Do you understand? Okay. So for cotangent, 1 over tan theta. When theta is 0, I'm going to have 1 over tan 0, and since tan 0 is 0, so I'm going to have 1 over 0, 1 over 0, and 1 over 0 will also give me undefined. It's also undefined fraction. Okay. So I'm going to have infinity as the answer. Infinity. Do you understand? Okay, the reason why I take time to explain this is because I'm dealing with this. Bro, are you getting it? So if you master 0 degree, we are still going to do the same for 30 degree. Are you getting it? So let us proceed to 30 degree. For 30 degree, we are still going to go the same way. Let's start with the sine. Let's start with sine. Okay. So we are done with 0 degree. So let's start with sine. What will be sine 30? Based on what we have on the board, what will be sine 30? Sine 30 degree. Let me use black pen. Sine 30 degree will be equals to, now, sine of any special angle is what? The root of finger below all over 2, right? Now we have 30 degree. How many finger is below this finger? That is 1. Do you understand? So I'm going to have sine 30 is equals to root of 1 all over 2. It's simple. Just pay attention. Sine of any special angle is equals to root of finger below all over 2. This finger that you see here belongs to what? 30 degree. This finger belongs to 30 degree. Now, root of finger below. How many finger is below this finger? That is 1, right? That's why I have root of 1 all over 2. Do you understand? Okay, root of 1 is what? 1. So I'm going to have 1 all over 2. So sine 30 is 1 over 2. 1 over 2 or 0.5. Do you understand? Okay, let's look at cos 30. cos 30 degree. Cos 30 degree is equals to root of finger above all over 2. Now, this finger belongs to 30 degree. How many fingers are above this this finger? That is what? 1, 2, 3. So I'm going to have root of 3 all over 2. Root 3 over 2 will give us 0.8660. Are you getting it? So, but we just leave your answer in short form. So that is what? Root 3 all over 2. Now, what of tan 30 degree? Tan 30 degree will be equals to, tan theta is what? Root of finger below all over root of finger above. Okay? Now, how many finger is below this finger? That is what? 1. So I'm going to have root 1 all over. How many finger is above this finger? 1, 2, 3. So I'm going to have all over root 3. That is what? 1 over root 3. And you can also rationalize. If you are part of our class in SWORD, if you want to rationalize this fraction, what are you going to have? You're going to have root 3 all over 3, right? Yes. If you rationalize this, so you're going to have root 3 over 3. You see, if you punch tan 30 degree in your calculator, you're going to have root 3 over 3. The reason is because the way your calculator is being programmed. You understand? For calculator that can bring out fraction, such as Ratio, if you punch tan 30 degree, you're going to have root 3 over 3. The reason why you're going to have that is because the way the calculator is being programmed. You understand? Now, for tan 30 degree, it is 1 over root 3 or root 3 over 3. Because if you rationalize this sword, you're going to have root 3 over 3. If you want, maybe you missed our class on sword, you can check the description of this video to watch the class, okay? So, or let's put or root 3 all over 3. Do you understand? Okay? So for this, I'm going to have, you can use anyone, root 3 over 3 or 1 over root 3. Do you understand? Okay. Now we are done with sine, cos, and tan of 30 degree. Let's proceed to the inverse. Okay. What of cosec? Cosec 30 degree will be what? Cosec. Okay, let's shorten it. Cosec 30 degree will be equals to 1 over sine 30 degree. 1 over sine 30 degree. And sine 30 degree is what? Sine 30 degree is 1 over 2. So I'm going to have 1 over 2. That is what? Please pay attention. 1 divided by 1 over 2, which is what? 2. Do you understand? Okay, the answer will be 2. If you don't understand, just take the 1 over 1 over 2 will be what? 2. Do you understand? And for the sec 30 degree, that will be what? Please pay attention. For sec 30 degree, you're going to have 1 over cos 30 degree. And you know that cos 30 degree is what? Root 3 over 2. That is what? 2 over root 3. Or root 3. Please pay attention. Or 2 root 3 over 3. Do you understand? Cos 30 degree, sec 30 degree will be equals to 1 over cos 30 degree. Do you know? And we know that cos 30 degree is what? Root 3 over 2. Are you getting it? So if you take the inverse of, please pay attention, 1 over root 3 over 2 will be equals to 2 over root 3. Do you know? And you know, I taught you sword, you understand? You can rationalize this. If you want to rationalize this, you're going to have multiply with 3. That is what? 2 with 3 all over 3. Do you get it? And you can also leave your answer in 2 as 2 over root 3. You are still the same. You are still going to be marked. Do you get it? So sec 30 degree is 2 over root 3. Do you get it? Now, what of the last one, which is cos 30 degree? Cos 30 degree is equals to 1 over tan theta, 1 over tan 30 degree. And we know that tan 30 degree is what? Tan 30 degree is root 3 over 3 or 1 over root 3. So that means that cos 30 degree will be what? Root 3 or 3 over root 3. 3 over root 3. Do you understand? Okay, so it's simple as that. Now, let's look at 45 degree. What of okay, let me erase this. It's simple, okay? See, Immediately you are able to get sine, cos, and tan. You are done with it. All the rest is just the inverse of what you have at the top. Do you get it? So that is what I want to just explain to you. So I'm going to be fast now. So I want you to pen it down and listen to the explanation carefully. Okay? What of sine 45 degrees? Sine 45 degrees will be equals to, since sine theta is what? Root of finger below all over root of finger above. Now we are here. This is the finger that we are considering now. Are you getting it? Now, the finger that is at the middle is what we are considering. That is for 45 degrees. And since sine theta is root of finger below all over 2, that means that how many finger is below this finger? 1, 2, right? So sine 45 degrees will be what? Root 2 over 2. Root 2 all over 2. Sine 45 degrees is root 2 all over 2. The reason is simply because sine theta is equals to root of finger below all over 2. And this is 45 degrees. How many finger is below 45 degrees? 1, 2. That is root 2 all over 2. Do you get it? That's how you get this. Now, what of cos 45 degrees? Cos 45 degrees will also be root 2 over 2. How do I know? You see, how many finger is above 45 degrees? We have 1, 2. So I'm going to have root 2 all over 2 because cos of any special angle is equals to the root of finger above all over 2. Hence, cos 45 degrees will be root of finger above. How many finger is above 45 degrees? 1, 2. That's what? Root 2 over 2. That is 0.7771. Root 2 all over 2, which will give us 0.7071. Now, what of tan theta? When theta is 45 degrees, what will be the value of tan 45 degrees? Tan 45 degrees will be root of finger below all over root of finger above. That is what? Root 2 all over root 2, because this is 45 degrees. How many finger is below 45 degrees? 1, 2. Right? How many finger is above? 1, 2. So root 2 all over root 2 will give us 1. Hence, the answer here will be 1. Are you getting it? Okay, now let us proceed to the inverse. Let's start with the inverse of sine. Inverse of sine is cosec. So cosec 45 degrees will be equals to 2 over root 2. Do you understand? 2 over root 2, or, please pay attention, or root 2. It's simple as that. Cosec 45 degrees will be 2 over root 2 or root 2. How do I get to root 2? I just rationalize, you understand? You see, surd is an important concept in mathematics, you understand? So if you want to learn surd, you can check the link in the description of this video and watch the class, okay? It's free. Now, 2 over root 2, if you want to rationalize 2 over root 2, you're going to have 2 root 2 all over 2. Are you getting it? And 2 root 2 over 2 is what? Root 2. Do you get it? So, the cosec 45 degrees will be root 2 or 2 over root 2. What of sec 45 degrees? Since we know that the inverse of cos will give us sec. So, sec 45 degrees will be inverse of cos 45 degrees. And cos 45 degrees is what? Root 2 over 2. So, what is the inverse of root 2 over 2? That was 2 over root 2. And if you rationalize, you're going to have root 2 also. Do you understand? Okay. What of cot 45 degree? Cot 45 degree. We all know that the inverse of tangent will give us the cot. Are you getting it? So the inverse of tan 45 degree will give us cot 45 degree. Inverse of 1 is what? 1. So I'm going to have 1 over 1 is what? 1. The answer here is 1. Do you get it? Okay. What of 60 degree? We are done with 0 degree, 30 degree, 45 degree. Now we are on 60 degree. How do we get the special angle? The values for 60 degree. We all know that sine theta is what? Root of finger below, all over root of finger above. Sine 60 degree will be root. This is the finger that belongs to 60 degree. You get it? This finger that you see here belongs to 60 degree. And we all know that root of finger below, all over 2 will give us the sine of any special angle. So sine 60, which is here, will be, how many finger is below this finger? 1, 2, 3, right? So that's what? Root 3 all over 2. Do you get it? Just use, you see, anytime you come across this kind of question in exam and you are not permitted to use calculator, just look at your finger and then begin to calculate, okay? So for this, I'm going to have root 3 over 2, which is equivalent to 0.8660. Root 3 all over 2. That will be what? Sine 60 degree, okay? What of cos 60 degree? Cos of any special angle is root of finger above all over 2. And this is 60 degree, right? Yes. So cos 60 degree will be root of finger above. How many finger is above 60 degree? That is what? 1. Right? So that is what? Root 1 all over 2. And root 1 is what? 1. Hence, I'm going to have 1 over 2 here. 1 over 2. Do you understand? Okay? what of tan 60 degree? Tan of any special angle is root of finger below all over the root of finger that's above. Okay, tan 60, we are here. How many finger is below? That is what we put 3, right? 3 finger is below. The first finger is this, the second is this, and the third is this. You understand? So, and since tan theta is root of finger below all over root of finger above, tan 60 degree is root of 1, 2, 3. Root of 3 all over the root of finger that is above, which is what? 1. So I'm going to have root 3 over 1. And root 3 over 1 is what? Root 3. Do you understand? Root 3 over root 1. Root 3 over root 1 will give us root 3. Do you understand? Because if you take the square root of 1, you're going to have 1. Do you understand? Okay, what of cosec 60 degree? Cosec simply means the inverse of sine. Are you getting it? So if I want to get cosec 60 degree, I just have to take the reciprocal or the inverse of sine 60 degree. And if I want to take the inverse or reciprocal of sine 60 degree, you're going to have 2 over root 3. Do you get it? 2 over root 3 or 2 root 3 over 3. It's simple as that. 2 over root 3 or 2 root 3 over 3. Do you understand? Okay? Sec simply means the inverse of cos. You understand? So sec 60 degrees simply means the inverse of cos 60 degree. And we all know that cos 60 degrees is what? 1 over 2. So the inverse of 1 over 2 will give us what? 2. So the value here will be what? 2. The value here is 2. Okay? Then we have cot 60 degree. Cot 60 degree simply means the inverse of tan 60 degree. And we all know that tan 60 degree is what? Root 3. Okay? So cot 60 degree will be what? 1 over root 3. 1 over root 3. And if you rationalize, you understand, you're going to have or root 3 over 3. You understand? That is cot 60 degree. Okay? Now, let's look at 90 degree. Sine 90 degree will be equals to 1. How do I know? It's simply because since sine theta is root of finger below all over 2, sine 90 degree will be root of finger that are below this finger. You know this finger belongs to 90. Are you getting it? So how many fingers are below this finger? 1, 2, 3, 4. So I'm going to have root of 4 all over 2. The square root of 4 will give me 2. So I'm going to have 2 over 2. That will give me what? 1. Okay? So sine 90 degree is 1. Do you understand? You can do it in a sheet of paper, you know. The reason why I'm just I didn't show the workings is because I've already told I've showed the workings for 0 degree and 30 degree. So it's still the same step. Are you getting it? Now, what of cos 90 degree? Cos of any special angle is root of finger that are above all over 2. So how many finger is above 90 degree? There is no finger that is above this finger. Are you getting it? This finger belongs to 90 degree. There is no finger that is above this finger. Hence, that's what? Root of 0 all over 2. So root of 0 is 0. 0 over 2 is what? 0. So the value of cos 90 degree is 0. Okay? Now let us proceed to tan 90 degree. Tan of any special angle is root of finger below all over the root of finger that is above. Okay? Now we have tan 90 degree. How many finger is below 90 degree? That is what? 1, 2, 3, 4. I'm going to have the square root of 4 all over the square root of 0 because there is no finger that is above 90 degree. Are you getting it? So square root of 4 is 2 and square root of 0 is 0. 2 over 0 is undefined. Are you getting it? So we are going to represent that as this sign, infinity. 2 over 0. We're going to represent it with this sign, infinity. Okay, now what of cosec 0 degree? The cosec of any angle is the 1 over sine of that angle. So cosec 90 will be 1 over sine 90. And since sine 90 is what? 1. So 1 over sine 90 will be 1 over 1. I'm going to have 1. Okay? Now, what of sec theta? Sec of any angle is the inverse of the cos. So 1 over cos 90 will be what? Cos 90 is what? 0. So 1 over 0 is undefined as well. So we are going to represent it with this sign, infinity. Okay? Now we have the cot, which is the last one. Cot of any angle is 1 over the tan of that angle. And tan 90 degree is what? Infinity. 1 over infinity is 0. You understand? So I'm going to have 0 here. Do you understand? Okay? So you can see that it is easy to complete any table on special angle provided that you have your hand with you. So anytime you are in an exam hall and you discover that you can't remember a special angle and you are asked to leave your answer in short form, just look at your hand. 0, listen, 0, 30, 45, this is 60 and this is 90. Okay, so you face yourself. Sine 60 degree equals 3 over 2. Cos 30 degree is also equal 3 over 2. Complementary angle. You know, so that's interesting. Just look at your hand and begin to draft out anything that the question demand from you. Okay, so that is the solution to that question. So another method to remember special angle is that you can make use of triangle. You understand? Let's start with 30 degree and 60 degree. Okay, 30 degree, angle 30 degree and 60 degree. Okay, draw an equilateral triangle. An equilateral triangle is a triangle that has all its sides and its angle equal. Do you understand? Okay, so I'm going to have here, draw an equilateral triangle. Now represent each side as 2. This will be 2, this will be 2, and this side will also be what? 2, because the sides and the angle are equal. Now if the sides and the angles are equal, that means that, please pay attention, that means that the angles will also be equal. Are you getting it? So here will be what? 60 degree. This will be what? 60 degree as well, and this will be 60 degree. Do you understand? Okay, draw a line that runs through from this angle to this point. Like divide this triangle into 2. That's what I'm trying to say. Okay, to divide this triangle into 2, that means that you're going to have something like this. Do you understand? Okay, with respect to what you have done here, that means that if the total length from this point to this point is 2, that means that from this point to this point will be what? 1, and from this point to this point will be what? 1. Do you get it? Okay, don't forget when I start the class, I told you you can use 2 methods to derive what you have on this board. And we are dealing with 30 degree and 60 degree. And in deriving a special angle for 30 degree and 60 degree, draw an equilateral triangle. An equilateral triangle is a triangle that has all its sides and its angle to be equal. So if all the sides and angle is equal, that means that I told you to represent each side as 2. So I have 2, 2, 2. Okay, then sum of angles in the triangle is 90 degree. So each angle will be what? 60 degree. Is that not it? Now I represent each angle at 60 degree. Then I ask you to divide the triangle into 2. Okay, so I divide the triangle into 2. That means that from this point to this point is 1, and from this point to this point is 1. So this angle here will go 30 degree, and this angle will go 30 degree. Do you understand? Okay, because the total angle that is here will go 60 degree. So this angle will be 30, this angle will be 30. Now bring out half of the triangle. Bring out half of the triangle. You see, we divide the triangle into 2, right? So bring out half of this triangle. So let us bring out triangle. Let me label A, B, C, D. Okay, let us bring out triangle ABC. You understand? Triangle ABC. This is triangle ABC. Triangle ABC. This place is 60 degree. This place is 30 degree. And this place is, this will be 90 degree. You know, some of angles on a straight line. This will be 90 degree. And this is 2. This is 1. Now, you can see that we have two special angle inside this triangle, even 3. But we are dealing with 2 now. 60 degree and 90 degree. Okay, 60 degree and 30 degree. Now please pay attention. We cannot use this triangle unless we get the length of this side. Are you getting it? And I've already taught you Pythagoras Theorem. Do you understand? To get the length of this side, all you have to do is that just take the difference of the square of this side and this side. Because in Pythagoras Theorem that I told you hypotenuse squared is equals to the opposite squared plus the adjacent squared. Okay, now hypotenuse is 2, so I'm going to have 2 squared is equals to the opposite squared. Opposite, we don't know it, so let's use opposite, or O. Let's use O. O squared is equals to O squared plus adjacent, which is 1. Okay, to get the value of O, what do? O squared is equals to 4 minus 1. Okay, O squared is equals to 3. To get the value of O, you take the square root of both sides. Opposite is equals to root 3. Okay, so this side will be what? Root 3. Do you understand? Okay, I just use that properties. You see, listen to me carefully. I just want to show you that this is the way they got the triangle. Okay, just when you are doing this in the exam, if you cannot remember this method, just bring out this triangle and You didn't need to show all the solution. The reason why I showed all the solution is because I want to help you to understand how they come about all these values. Because 2, 1 with 3 and others. Are you getting it? So yeah, you didn't have any problem with that, right? Now we have gotten the opposite side. Now let us look at sine, cos, and tan of 30 degree and 60 degree. Okay, let's start with 30 degree. Please pay attention. Okay, please pay attention. I've already told you, I've taught you how to identify the sides of a right angle triangle. In a right angle triangle, we have the opposite, adjacent, and hypotenuse, right? And I told you that the side that the angle that you are considering, the side that it faces, angle to conduce on that angle is called the opposite. Do you understand? Okay. Now we are considering. Please pay attention. Sine 30, cos 30, and tan 30. Okay, now we are considering angle 30 degree now. The side that angle 30 degree face is called the opposite. You understand? Do you understand what I'm saying? The side that angle 30 degree face in this right angle triangle is called the opposite. The side that angle 90 degree face is called the hypotenuse. And you understand? And the third side will be regarded as adjacent. Do you understand? Okay, now we have sine 30 degree. Which side does sine 30 degree is what? So opposite over hypotenuse, you know. So which side does this 30 degree face? This 30 degree face this side. You understand? That means that for 30 degree, for angle 30 degree, this side will be regarded as what? Opposite. Are you getting it? And this side will be regarded as what? Hypotenuse. Hypotenuse. Why this side will be what? Adjacent. For angle 30 degree. Don't forget what I told you. We are now focusing on angle 30 degree. We have already neglected 60 degree. Are you getting it? You see, understanding trigonometry is crucial because if you didn't understand the basics now, a more advanced one, you might not be able to comprehend it at all. Are you getting it? So please pay attention. Sine 30 will now be so, which is opposite 1 over hypotenuse, which is 2. So sine 30 is what? 1 over 2. So what of cos 30? Cos 30 is what? Adjacent over hypotenuse. The adjacent is what? Root 3. Okay? Adjacent, which is root 3 all over hypotenuse. Hypotenuse is 2. So I'm going to have 2. What of tan 30? Tan 30 degree will be what? 12. Opposite over adjacent. The opposite now is 1 and the adjacent is what? Is root 3. So I'm going to have 1 over root 3. And I told you that 1 over root 3 is always the same thing as root 3 over 3. Because if you rationalize, you're going to have root 3 over 3. Okay? Now, listen. Let us check. Maybe we have the same result as when we use our finger. You know, I just drew out a finger, the previous method that I taught you. Let us check. Maybe we are still going to arrive at the same answer. Sine 30 degree is 1 over 2. Okay? Sine 30, you can see 1 over 2. So we are correct. What of cos 30 degree? Cos 30 degree is root 3 over 2. Okay? Cos 30, you can see is root 3 over 2. That means we are correct. What of tan 30 degree? Tan 30 degree is root 3 over 3. Okay? So tan 30 is root 3 over 3 or 1 over root 3. You see, it's still the same. So if you didn't remember this method, use the second method. Okay? So now we are done with 30 degree. Let us look at 60 degree. Let's look at 60 degree. What we did here is what? 30 degree. Let us look at 60 degree. Sine 60, cos 60, and tan 60. Okay? Sine 60 degree, I told you that. Now listen, we are now focusing on angle 60 degree now. You know, the previous one we focused on angle 30 degree. Okay, now we are considering angle 60 degree. Now I told you that the side that faces the angle that you are considering is what? Opposite. So the side that faces angle 60 degree is what? Opposite. So this angle is now opposite. This is hypotenuse, and this is what? Adjacent. Do you understand? That is the importance of what I taught you in the when I start this class. Identification of sides in a right angle triangle. Okay. Now, sine 60 degree will be opposite over hypotenuse. Okay. That will be what? Root 3 over 2. Root 3 all over 2. What of cos 60 degree? Cos 60 degree will be what? Adjacent over hypotenuse. That's what? 1 over what? 1 over 2. Okay. 1 over 2. And tan 60 degree will be what? Opposite over adjacent. So that is what? Opposite is root 3 over 1. And root 3 over 1 is what? Root 3. So this is root 3. root 3. Do you understand? Okay, let us check whether our answer is correct. We have sine 60 degree. Sine 60 degrees root 3 over 2. You can see it is correct. You see, just master any of the method, okay? We are still going to have the same answer. This is correct. What of cos 60? 1 over 2. Correct. What of tan 60? Root 3. Correct. Okay? So you can see that any of the method that you use will still give you the same result. So it's left for you to choose the method that you remember. Okay, for angle 45 degree, just draw a right angle triangle, and then this is 45 degree, this is 90 degree, then put 1 and 1. Okay, for 45 degree, just draw something like this. Now, to get this size, use the Pythagoras Theorem, because you know that this will be what? Hypotenuse, right? So according to Pythagoras Theorem, hypotenuse squared is equals to the opposite squared plus the adjacent squared. Okay, so hypotenuse squared is equals to opposite squared. The opposite is what? 1. So I'm going to have 1 squared plus 1 squared. Hypotenuse squared is equals to 2. Take the square root of both sides. Hypotenuse is equals to the square root of 2. Okay, so here I'm going to have the square root of 2. Please pay attention. This is the opposite, this is the adjacent, and this is what? Hypotenuse. Okay, so sine 45 degree will be equals to opposite over hypotenuse. The opposite is 1, hypotenuse is root 2. So I'm going to have 1 over root 2, 1 over root 2, or root 2 all over 2. Do you understand? And what of cos? Cos 45 degree will be equals to 1 over root 2 also, or root 2 all over 2. You see, cos is adjacent over hypotenuse, right? And adjacent is 1, hypotenuse is root 2. So 1 over root 2 is equals to cos. And if you rationalize, you're going to have root 2 over 2. Okay? Now, what of the tan 45 degree? Tan 45 degree will be equals to opposite over adjacent. Opposite is 1, adjacent is 1. So I'm going to have 1 over 1. 1 over 1 is what? 1. So let us check if what we have here is correct. Sin 45 is root 2 over 2. Cos 45 is root 2 over 2. And tan 45 is 1. You see, root 2 over 2 is also the same thing as 1 over root 2. You understand? So if you want to learn more on sword, you see, just check the link in the description of this video. You're going to see some links there. Watch all the videos. You're going to have a comprehensive knowledge on sword. Okay, so let's consider the following question on special angle. Without using calculator or four-figure table, evaluate 2 sine 60 degree minus cos 30 degree. Okay, without using calculator or mathematical table, evaluate, please pay attention, evaluate 2 sine 60 degree minus cos 30 degree. Now, listen to me carefully. If you want to solve this question, you are not permitted to use calculator, you are not permitted to use four-figure table. That means that all you have to do is that you are asked to use the special angle. I get what I'm trying to say. And that's why I take time to explain what we have on this table. Do you understand? Okay. Now, we have sine 60 degree and we have cos 30 degree. Those are the trigonometry ratio that we have in the question. Okay. From the special angle, sine 60 degree is what? Sine 60 degree is root 3 over 2. So I'm going to have sine 60 equals to root 3 all over 2. What of cos 30? Cos 30 degree, let's say, cos 30 degree is what? Root 3 over 2 as well. Cos 30 equals to root 3 all over 2. Okay? Now, with respect to what we have on the board now, we can substitute the value of sine 60 as root 3 over 2 and cos 30 degree as root 3 over 2 in the equation that we're asked to solve. Okay? So for this, I'm going to have 2 sine 60 degree. Instead of sine 60 degree, I'm going to have root 3 over 2. So that will be what? Root 2 multiplied root 3 over 2 minus, please, are we there? 2 multiplied root 3 over 2 minus cos 30 degree. Cos 30 degree is what? Root 3 over 2. So I'm going to have minus root 3 all over 2. Okay? 2 root 3 all over 2 minus root 3 over 2. Open the bracket. I'm going to have 2 root 3 all over 2 minus root 3 all over 2. Okay? You can simplify. I'm going to have these two, we cancel these two. I'm left with what? Root 3 over 2. So root 3 minus root 3 all over 2. Do you understand? Okay, now having gotten to this point, please pay attention. Having gotten to this point, the next step, take the LCM. The LCM is what? 2, right? So I'm going to have 2 divided by 1 is what? 2. 2 times root 3. 2 root 3 minus root 3. Do you understand? Okay, 2 root 3 minus root 3, that will be what? Root 3. You understand? For example, if you have 2x minus x will give us what? X. So 2 root 3 minus root 3 will give us root 3. So I'm going to have root 3 all over 2. And listen to me carefully. From this point, I know the answer. Are you getting it? But I want us to simplify it to help you to understand what we are even talking about. Okay? From this point, 2 root 3 over 2 minus root 3 over 2 will always be equals to root 3 over 2. Are you getting it? Just like if you have 2x minus x will give us x. Do you understand? And you know, that is why I said sword is an important part of mathematics. It's an important aspect of mathematics. So if you missed the class on sword, I talk about addition, subtraction, multiplication, division, conjugate, rationalization, and other aspects. If you missed the class, you can check the link in the description of this video. Make sure you watch the class, okay? It is very important that you know how to simplify sword, you understand? Because you see, this one that you have here is in sword form. And if you are not good with simplification of sword, you might find it hard to get the correct answer, okay? Now, let's proceed to the next question. Okay. Simplify sine 30 degree minus cos 30 degree all over sine 60 degree. We are asked to simplify sine 30 degree minus cos 30 degree all over sine 60 degree. Now, how do we simplify this without using calculator or mathematical table? All you have to do is that just go back to your table. I get what I'm trying to say. Go back to the table of special angle. Now listen. Anytime you're asked to simplify it without using mathematical table or calculator, all they are going to give you a special angle. I get what I'm trying to say. All the angles that you are going to be that is going to contain in the question that you are given will be special angle. For example, you can see that 30 degree is also part of the special angle. Likewise, 60 degree is also part of the special angle. Okay. So now, how do we simplify it? Don't forget that sine 30 degree is what? 1 over 2 from the table. So sine 30 equals to 1 over 2. What of cos 30? Cos 30 is what? Root 3 over 2. So cos 30 degree equals to root 3 all over 2. Okay, we still need sine 60. What of sine 60 degree? Sine 60 degree is what? Root 3 over 2. So sine 60 degree equals to root 3 all over 2. Are you getting it? Okay. Now, having listed all the angles, the next step is to substitute all the angles that you listed into the equation that you're asked to evaluate. Okay. So for this sine 30 degree will be what? 1 over 2. I'm going to have 1 over 2 minus cos 30 degree. Cos 30 degree is what? Root 3 over 2 minus root 3 all over 2. Are you there? Divided by sine 60 degree. Sine 60 degree is what? Root 3 all over 2. So I'm going to have divided by root 3 all over 2. Do you understand? Okay. Having gotten to this point, the next step is to take the LCM of the numerator. Okay. The LCM of the numerator is what? Is 2. So I'm going to have 2, 1 minus root 3 all over root 3 all over 2. Do you understand? Okay. Having gotten to this point, please pay attention. You have to, if you are solving this in objective, you have to show all your steps. Do you understand? But if you are solving this in theory, you might just skip it, and then, you know, if you are able to simplify it without showing all your steps, you can do that. Okay, now for this, I'm going to rewrite, listen, 1 minus root 3 all over 2, this division sign, put it here, divided by root 3 all over 2, right? I've not done anything. All I did was that I just changed this fraction that you see here. 1 minus root 3 over 2 is this division sign is this, and root 3 over 2 is this. Do you understand? Okay. For this, I'm going to have 1 minus root 3 all over 2 multiplied by 2 over root 3. You know, I changed this division sign to a polka dot sign. And if I change it to a product sign, that means that there will be interchange. I'm going to interchange the numerator and the denominator of the fraction that I have here. Okay, that is why this 2 becomes the numerator and this 3 becomes the denominator. Do you understand? Okay, from this point, this 2 can eliminate this 2. So I'm left with what? 1 minus root 3 all over root 3. Okay, now please listen to me carefully. There is something called rationalization in SOLD. Do you understand? Having gotten to this point, if this is an objective question, you might not find these options in the answer. Okay, they might expect you to rationalize. Okay, and if you want to rationalize this, you want to make the denominator not to have any square root. You understand? This denominator, the denominator of this fraction contains an irrational part. Irrational part is the part that is covered with square root. You see, root 3 is present at the denominator, and square root of 3 is an irrational part. You understand? So when we talk about rationalization, we are trying to remove the irrational part at the denominator. Are you getting it? So for this, to do that, I'm going to multiply both the numerator and the denominator by root 3. Do you understand? If you want to learn more on rationalization of SOLD, check the link in the description of this class. Okay? This multiply root 3 over root 3. Root 3 times 1, that is what? Root 3. Root 3 times negative root 3, that is what? Minus root 9, right? Yes. Minus root 9, because root 3 times root 3 is 9. Are you getting it? Root 9 is sorry. So I'm going to have this over 3. Okay? Now, what will be the answer for this? I'm going to have root 3. Root 9 is what? Okay, root 3 minus 3 all over 3, right? Yes. Okay, minus 3 plus root 3 all over 3. Yes. You can separate the fraction. You can leave your answer like this, and you can also separate the fraction. If you want to separate this, I'm going to have minus 3 all over 3 plus root 3 all over 3. Do you know? Yes. Okay, minus 3 divided by 3 is what? Minus 1. So I'm going to have minus 1 plus root 3 all over 3. Do you understand? And you can also leave your answer like this, depending on how you want it. So that is the solution to the second question. Let's look at the third question. Evaluate sin 30 degree plus tan 45 degree minus cos 60 degree without using calculator or mathematical table. Okay, we have sin 30 degree plus tan 45 degree minus cos 60 degree. Okay, now listen to me carefully. You know that sin 30 degree on this table is what? 1 over 2. So I'm going to have 1 over 2 plus what of tan 45 degree? Tan 45 degree is what? 1. Do you know? So I'm going to have plus 1 minus cos 60 degree. Cos 60 degree here will be what? 1 over 2. So I'm going to have minus 1 over 2. Okay? Now, even without simplifying or looking at it, what will be the final answer? The final answer will be 1. Do you know? Well, but let us simplify. According to board mass, you first deal with the addition sign, right? So take the LCM. The LCM is 2. I'm going to have 1 plus 2 minus 1 over 2, right? 3 over 2 minus 1 over 2, right? 3 over 2 minus 1 over 2. The LCM here is what? 2. So I'm going to have 3 minus 1, which is equals to 2 over 2. 2 over 2 will be 1. Do you understand? Okay, so the solution to sin 30 degree plus tan 45 degree minus cos 60 degree is 1. Do you understand how I got 1? Okay, I just simplified the fraction. And even without simplifying, you know that you have a positive 1 over 2 here, you have a negative 1 over 2. This will cancel this, so we are left with 1. The answer is 1. Do you get it? Okay, so that is the solution to the third question. Let us look at the fourth question. Please, I hope you are getting what I'm doing. If you didn't understand, let me know in the comment section, okay? We are asked to solve cos 60 degree minus sin 60 degree all over sin 60 degree plus cos 60 degree without using calculator or mathematical table. Now, let's go back to the table that we have here. We need cos 60 degree. Cos 60 degree is what? Root 3 over 2. So I'm going to have cos 60 equals to root 3 all over 2. What of sin 60? Sin 60 is what? Oh, sorry. Cos 60 is root 3. Oh, is 1 over 2. Sorry. Cos 60 is 1 over 2. Please, you have to pay attention to what you are doing, okay? I made a mistake now, and I want to learn from it. Cos 60 is 1 over 2. Are you there? Now sine 60 is what? Root 3 over 2. So I'm going to have sine 60 here. Sine 60 degree equals to root 3 all over 2. Sine 60 cos 60. Okay? So every of the trigonometric ratio that is present in this question, we have already listed them. Are you getting it? Now the next step is to substitute each value into what you are given. Okay? Cos 60 is 1 over 2. I'm going to have 1 over 2 minus sine 60. Sine 60 is what? Root 3 over 2 minus root 3 all over 2 divided by, okay, what of sine 60? Sine 60 is what? Root 3 over 2. I'm going to have root 3 all over 2 plus cos 60. Cos 60 is what? 1 over 2 plus 1 over 2. Okay? Having gotten to this point, the next step is to simplify. Do you understand? Okay, let's simplify what you have here. For this, I'm going to have the LCM of the numerator will be 2. So I'm going to have 2, 1 minus root 3. Do you understand? And what of the denominator? The denominator is what? Root 3 over 2 plus 1 over 2. Now, the LCM of root 3 over 2 plus 1 over 2 is what? 2, right? So I'm going to have 2. And the numerator will be what? Root 3 plus 1. Do you get it? Okay. The next step now is that just simplify what you have here. I'm going to have 1 minus root 3 all over 2 divided by root 3 plus 1 all over 2. Okay, change this division sign to multiplication sign. We're going to have 1 minus root 3 all over 2, 1 minus root 3 all over 2, multiply 2 all over root 3 plus 1. Okay, you cancel this. So we are left with what? 1 minus root 3 at the numerator now. 1 minus root 3 all over root 3 plus 1. Root 3 plus 1. Okay, now listen to me carefully. When you get to this point, if you are solving this in theory, make sure you rationalize. You understand? Rationalization of solved means removing the irrational part at the denominator. Do you understand? Okay, and to rationalize this solved, what are you going to do? You just have to multiply both the numerator and the denominator of this solved by the conjugate of the denominator. And the simple reason is simply because at the denominator we have a mixed solved. You understand? Okay, we have a compound solved. So I'm going to multiply both the numerator. Numerator is 1 minus root 3. Denominator is root 3 plus 1. The conjugate of the denominator is root 3 minus 1. So I'm going to multiply both the numerator and the denominator by root 3 minus 1. So I'm going to have this multiply root 3 minus 1, root 3 minus 1. Do you get it? So we're going to have 1 minus root 3 multiplied by root 3 minus 1. Okay, this all over root 3 plus 1 multiplied by root 3 minus 1. Do you understand? Okay, now the next step is to take the product of both the numerator and the denominator. 1 times root 3, what will be the answer? Root 3, right? Yes. We're going to have root 3. 1 times minus 1, that is what? Minus 1. Minus root 3 times root 3, that is what? Minus 3. Minus 3, okay? Minus root 3 times minus 1, that is what? Plus root 3, plus root 3. Do you know what I did? If you have something like this, a plus b, what will be the answer? This times this, a squared. A times b plus ab, b times a plus ab, b times b plus b squared. Is that not it? So I just multiply this bracket. 1 multiply by everything here, minus root 3 multiply by everything here. Are you getting it? So this all over root 3 times root 3, that is what? 3. Root 3 times minus 1, that is what? Minus root 3. Plus 1 times root 3, that is what? Plus root 3. Plus 1 times minus 1, that is what? Minus 1. Okay? Now from this point, you can still simplify. You can still simplify. Let me erase this. Okay? We have root 3 plus root 3. That is what? 2 root 3, right? Minus 1 minus 1. That is what? Minus 4. Okay? That is what? Minus 4 plus 2 root 3. Listen to me carefully. I just add root 3 and root 3 together, just like adding x and x. Are you getting it? I just collect like terms. Okay? So root 3 plus root 3, that is what? 2 root 3. Are you getting it? Minus 1 minus 3. That is what? Negative 4. So I have negative 4 at the denominator. I mean, negative 4 plus root 3 at the numerator. Now, let's proceed to the denominator. At the denominator, we have 3 minus root 3 plus root 3 minus 1. Okay? Minus root 3 plus root 3 will eliminate each other. So I'm left with 3 minus 1. 3 minus 1 will give us 2. So I'm going to have this over 2. Okay? You can still proceed to simplify. Separate the fraction. You're going to have minus 4 all over 2 plus 2 root 3 all over 2, right? Yes. Minus 4 divided by 2 is what? Minus 2. Minus 2, yes, plus this 2 will eliminate this 2. So we are left with what? Root 3. So this the final answer is minus 2 plus root 3. Do you understand? Okay? You know, when I start this question, I first identify the trigonometric ratio that I have in the question. I have cos 60 and sin 60. Okay? So I go back to the table. Cos 60 is 1 over 2. According to the table, cos 60 is 1 over 2. And sin 60 degree is root 3 over 2. Sin 60 is root 3 over 2. Then, having done that, I just substitute both into what I have here. Do you get it? So, having substituted all this, I arrive at this. Then I change this division sign to multiplication sign. Hence, the denominator of the second fraction will change to numerator, and the numerator will become the denominator. So, these two eliminate these two. So, I arrive at this fraction. Then I taught you rationalization of surd in our previous class. So, I rationalize this to eliminate the square root at the denominator. Do you understand? So, and by rationalizing a compound surd, what you have to do is that just multiply the numerator and the denominator by the conjugate of the denominator. Do you understand? Okay. So, I take their products. 1 times root 3, 1 times minus 1, minus root 3 times root 3. That is what? Minus root 9. And root 9 is root 3. That's why I have minus 3. Okay. Minus root 3 times minus 1. That is what? Plus root 3. Okay. And at the denominator as well, root 3 times root 3 will give me 3. Root 3 times minus 1, minus root 3, plus 1 times root 3, that is what? Plus root 3, plus 1 times minus 1, that is what? Minus 1. So, this eliminates this, so I'm left with 3 minus 1 at the denominator. 3 minus 1 is what? 2. And at the numerator, I also collect like term, so I got minus 4 plus root 3, minus 4 plus 2 root 3. So, I then divide both the numerator, I divide the numerator by the 2 that I have at the denominator. So I got minus 2 plus root 3. Do you understand? Evaluate 2 tan 45 degree minus tan 60 degree without using mathematical table. Evaluate 2 tan 45 degree minus tan 60 degree without using mathematical table. Now, don't forget that tan 45 degree is what? That is 1. So I'm going to have 2 multiplied by 1. All I did was that I just replaced tan 45 degree as 1, because on this table, this is 45 and tan 45 degree is what? 1. Okay? Minus tan 60 degree. Tan 60 degree on this table is what? Is root 3. So I'm going to have minus root 3. Okay? So 2 times 1 is what? 2. So I'm going to have 2 minus root 3, which is the final answer. Do you understand? Okay, so anytime you come across question on trigonometry asking you not to use mathematical table or calculator, know that you are asked to use this. Do you understand? Okay, so that will be all on special angle. So let's go over random questions on trigonometry. Let's consider the question that we have on the board. We are asked to calculate the marked side. Okay, for question 1, we have 8 centimeters here. We have x, we have 41 degree as the angle that we are given. We are asked to find the value of x in the question 1. How do we solve for the value of x? Well, to do that, don't forget that when I start this class, I taught you a mnemonic device known as SOHCAHTOA. SOHCAHTOA. Okay? Now, we are going to use one of these mnemonic device, one of the trigonometric ratio to find the value of x. Now, before that, let us identify the side which x is. You know, in this right angle triangle, we have 3 sides. We have the opposite side, we have the adjacent side, we have the hypotenuse side. Okay. Now, since we are given the angle as 41 degree, the side that this 41 degree face is 8 centimeters, and this side will be the opposite. You understand? The side that the angle that you are given face is the opposite. This is the opposite. Now, the side that faces angle 90 degree, you see this angle that you see here is 90 degree. Anytime you come across any triangle and you have something like this, just know that this angle is 90 degrees. Are you getting it? Now the side that faces this angle is angle x. That means that this the side that faces this angle is side x. So side x will be the hypotenuse. Do you get it? And the third side will be the adjacent. Do you understand? Okay. Now, having identified all the sides, we are looking for the hypotenuse. We know the angle. We are given the opposite. The opposite is 8 centimeters. What trigonometric combination can we combine together? What trigonometric ratio combine opposite and hypotenuse? Is it so is it car or toa are we going to use? That one depends on what you are given. We are given opposite, we are looking for hypotenuse. Opposite, hypotenuse. So if I want to use car, that means I'm going to have cos theta equals to adjacent over hypotenuse, right? So I'm not going to use car. Let's see. So is what? Sine. Sine is what? Opposite over hypotenuse. Car is what? Cos. Cos is equals to adjacent over hypotenuse, right? Now what of tan? Tan is equals to opposite over adjacent. Now, looking at what I wrote on the board, what trigonometric combination can we use with respect to the value of x that we are asking to find? We are looking for hypotenuse, right? So what we're going to use is sine. We cannot use car. The reason is simply because we are not given the adjacent. Are you getting it? Assuming we are given the adjacent, we are not given the adjacent, we are also not given the hypotenuse, so we cannot use car. What of tan? Tan is opposite over adjacent. Okay, the opposite has been given in 8 centimeters. The adjacent is not given, but we are not looking for the adjacent, we are looking for the hypotenuse. So the trigonometric ratio that fits in for what we want to do is sine, and that is what we are going to use sine. Sine of the angle that we have here will be equivalent to sine 41 degree equals to opposite. The opposite is 8 centimeters. 8 centimeters all over hypotenuse, which is x, all over x. Okay, the next step is to cross multiply. So we are going to have x sine 41 degree equals to 8, right? Okay, to get the value of x, what do you do? Divide both sides by sine 41 degree. Sine 41 degree, sine 41 degree, okay? So x is equals to 8 over sine 41 degree. What's your calculator? Sine 41 degree will give us 0.6561. 0.6561, okay? Now divide 8. 8 divided by 0.6561. That is 12.19, okay? X is equals to 12.19, okay? Now depending on you can approximate to a whole number, okay? X is equals to 12 centimeter, okay? So the value of x is 12 centimeter. Do you understand? That is the solution to question A, okay? What of question B? In this question B, we are looking for the length of this point to this point, okay? How do we get the length from this point to this point? Well, to do that, please pay attention. The second question now. We are asked to find the value of y. Look at we have two triangles in this triangle, right? Yes, we have triangle. Let's label it. Let's call this one A, B, C, D. Okay, we have two triangles in this triangle. The first triangle, let me call this point C. Okay, point C. This point is C. Okay, we have two triangles in this diagram. The first triangle is triangle ABC, and the second triangle is triangle ABD. Okay, now we are looking for the length. The value of y is what we are looking for. The value of y is the length from this point to this point. So to calculate the value of y, what are you going to use? Are you going to make use of 60 degree or 45 degree? We have two triangles. We also have two given angles. We are given this place as 60 degree. We are given this place as 45 degree. So if you want to calculate the value of y, which of this angle are you going to use? We are going to make use of 45 degree. Do you know the reason? The reason is simply because if you want to make use of 60 degree, that means that the length that you're going to have will be from this point to this point, okay? But because 45 degree covers from this point to this point, so we're going to make use of 45 degree. Hence, you can bring out triangle ABD. Triangle ABD. Triangle A Sorry for my drawing. Triangle ABD. Triangle ABD, this is what? 45 degree ABD. Okay? This triangle ABD. This length will be what? Length Y. Okay? So to get the value of Y, it's simple. This is what? 5 centimeter. 5 centimeter. To get the value of Y, it's simple. Listen, if I want to make use of triangle ABC, I'm not going to get the full length. The full length is what I'm asked to calculate. The full length from this point to this point is what I'm asked to calculate. But if I want to make use of this triangle ABC, I'm only going to get the length from this point to this point, and we are not going to get an accurate answer. Do you understand? Okay. So how do you calculate the value of Y? To get the value of Y, we have been given the what? Opposite. This is the hypotenuse, right? And this is the adjacent. Okay. So we have been given the opposite. We are looking for the adjacent. What trigonometric ratio are we going to use? Are we going to use sine? Let's try. We are given the opposite. We are not looking for hypotenuse, so we cannot use sine. We are given the opposite. Opposite is not even present here. We cannot use cos. So the right trigonometric ratio that is suitable to calculate the value of Y is tan. You understand? So I'm going to have tan 45 degree. Tan 45 degree equals to opposite. The opposite is what? 5 centimeter. 5 all over adjacent. Adjacent is Y all over Y. Okay. So the next step is to cross multiply. If you cross multiply, you're going to have Y tan 45 degree equals to 5, right? To get the value of Y, divide both by tan 45 degree. Y equals to, okay? Tan 45 degree will give us 1, right? Yes. Okay. So I'm going to have Y equals to 5 all over 1. Y equals to 5 centimeter. Okay. So the value of Y is 5 centimeter. Do you understand? Okay. What of the third question? Okay. The third question. We are asked to find the value of Z. How do you get the value of Z? We have two triangles in this diagram as well. The first, let us label A, B, C, D. Okay. The first triangle is triangle A, B, C. Okay. The second triangle is triangle A, C, D. Now, if I want to calculate the value of Z, I can bring out Z. Listen to me. Z belongs to which triangle? Z belongs to triangle ACD. We are even having we are even having three triangles. You understand? We are having three triangles in this diagram. The first triangle is triangle ABC. The second is triangle ACD. The third triangle is the triangle ABD. Are you getting it? But notwithstanding, what we are interested in is the value of Z. Are you getting it? So what you are going to do now is that since Z belongs to triangle ACD, just bring out triangle ACD. So triangle ACD will be this. This is triangle ACD. ACD. Okay. This is 30 degree, and this is 90 degree. Okay. Triangle ACD. Now, we are given that in triangle. Please listen to me. From triangle ABC, line AB is what? 12 centimeter, right? Please pay attention. It's very important that you pay attention. Triangle ABC, line AB, the distance from this point to this point is 12 centimeter. Why do they give us this distance? The simple reason is simply because we are going to need the distance to calculate the opposite. You understand? So from triangle ABC, you can get the value of AC. You can get line AC from the distance from this point to this point. Because if you know the distance from this point to this point, you can use it to calculate the value of Z. Do you understand? Okay, so let us get the distance from this point to this point. And to do that, just bring out triangle ABC also. Triangle ABC. From triangle ABC. From triangle ABC. We're going to have something like this. Where this is 45 degree. 45 degree. And this is 12 centimeter. And this is B. This is C. And this is A. Okay. What we are looking for is now the opposite. You understand? Because this side we need it. If I know this side that you see here is not the same thing as this side. So if I want to get the value of Z, I need this side. And from triangle ABC, I can get this side. You understand? Because we've been given the what? Hypotenuse as 12 centimeter, okay? So to get the value of Z, since Z belongs to the opposite, you can make use of, we are given the hypotenuse, we are looking for the opposite. What trigonometric ratio are you going to use? Make use of sine. You understand? So I'm going to have sine theta. Now theta is 45 degree. Sine 45 degree equals to opposite is what you are looking for. Opposite, let's represent it as x. X, let's represent it as x. X over hypotenuse, which is 12, okay? So x is equals to 12 sine 45 degree. Do you get it? Okay, so I'm going to have x is equals to 12 multiplied by sine 45 degree is what? Root 2 over 2. You get it? Root 2 all over 2. Do you understand? So 12 here and 2 here 1, 2 here 6. So I'm going to have x equals to 6 root 2. That is the value of x. That means that the opposite now is what? 6 root 2. 6 root 2 centimeter. You can put it in any don't mind me, okay? You see, you can put it in decimal form. It depends on you. Are you getting it? But I just taught you special angle, so you shouldn't find it hard to comprehend at all, okay? In special angle, sine 45 degree is root 2 over 2 or 1 over root 2. Do you understand? So you shouldn't find that one to comprehend, okay? And if you want to put it in decimal, sine 45 degree is 0.7071. 0.7071. And multiplying it by 12, you're going to have 12 times 0.7071. That will give you 8.4852. And if you punch 6 root 2, you are still going to have 8.4852. You understand? So it depends on you. Okay, so we have gotten the the opposite as 6 root 2. You see, what connects, listen to me, what connects triangle ABC and triangle ACD is this opposite. You understand? So the opposite is for both of them. This side that you see here is for both of them. So if this side is 6 root 2 for triangle ABC, it is also 6 root 2 for triangle ACD. 6 root 2. Do you understand? It is also 6 root 2 for triangle ACD. Now, having gotten to this point, the next step is that we cannot proceed to calculate the value of Z. How do we do that? All you have to do is that, since you know that opposite is now 6 root 2, the opposite is now 6 root 2, and because this is the side that faces the angle 90 degree, that means that this side is what? Hypotenuse. So to get the value of Z, you're going to make use of sine. Sine 30 degree equals to opposite. The opposite is 6 root 2. 6 root 2 all over the hypotenuse. The hypotenuse is Z. So I'm going to have Z sine 30 degree equals to 6 root 2, right? Do you know? Are you getting it? And sine 30 degree is what? 1 over 2. So I'm going to have Z multiplied by 1 over 2 is equals to what? 6 root 2. Do you get it? Okay. So I'm going to have Z over 2 is equals to 6 root 2. To get the value of Z, you just have to cross multiply, okay? So I'm going to have this over 1. If you cross multiply, you're going to have Z. This is Z, okay? Z is equals to 12 root 2. Are you getting it? And if you want to put it in decimal, it's simple. That will be what? 16.97. Z is equals to 16.97. Is it centimeter? Okay, it's centimeter. 16.97 centimeter. Do you understand? Okay, so that is the solution to that question. You see now, listen to me carefully. The summary of what I'm telling you now is that the trigonometric ratio that you are given and that you are going to use depends on the side that you are given. Are you getting it? And the side that you are asked to calculate. Are you getting it? The trigonometric ratio that you are going to use depends on the side that you are given on the side that you are asked to calculate. Okay, now listen. The side that we are given here is the opposite, right? And the side that we are asked to calculate is what? Is the hypotenuse. So what do I use? I make use of the trigonometric ratio that combines both opposite and hypotenuse, and that is sine. So I have this as the final answer. Okay, what of the second question? We are asked to calculate the length from this point to this point. Okay, and to get the length from this point to this point, that means that I have to make use of, this is the adjacent, you know, the adjacent of the bigger triangle ABD. The adjacent is what? BD, which is Y. And if this is the adjacent, we have been given the opposite, because I told you that the side that the angles that you are given face is what? Is the opposite. So you are going to make use of tan, because tan combine both the opposite and the adjacent together. Do you understand? And I get the value of y as 5 centimeters. Don't mind the diagram, okay? I know that the length is supposed to be the same. Like the length, this 5 centimeters is supposed to be, if you look at this length, you will just discover that it is the length is greater than this length. But don't mind the diagram, okay? That's the correct answer. Now, what of question C? From question C, we are asked to calculate the value of Z. Here we have three triangles. I just split the triangle. I label the side ABC and ACD and also ABD. But we are not interested in the bigger triangle. So I split the triangle into two. So I bring out triangle ACD. But I cannot calculate the value of Z without knowing this side. You understand? So, and I've been given that from triangle ABC, the hypotenuse side is 12 centimeters. So I make use of this triangle to get the value of this side, and I got it as 6 root 2. So before that, I proceed to calculate the value of Z using sine 30 degree. Then the value of Z is 12 root 2 or 16.97 centimeters. So it's simple. Don't worry. If you want more questions on this particular concept, check the link in the description of this video. Let's consider the following question on trigonometry. We are asked to calculate the marked side in the following triangle. Okay, let's start with the first question. Here we are looking for this side, which is x, and we're also looking for this side, which is y. Now, before we can calculate the value of y, we can get the value of x, right? Because in the bigger triangle, that is triangle ABD, triangle ABD, triangle ABD. This is triangle ABD. This is triangle ABD. We have x here. This angle is 30 degrees. And we have the right angle here. And then we have that this side is what? 8 centimeters. Okay? From triangle ABD, we can get the value of x, because you know that I told you that the side that faces the angle 90 degrees is the hypotenuse side. And we are looking for the side that faces the angle that we are considering. That is what? The opposite side. Oh, so I'm going to have this opposite, while this is hypotenuse. Now, with respect to what we have on the board, what trigonometric ratio are we going to use if we want to get the value of x? We know that the hypotenuse is 8 centimeters. We are looking for the opposite. Hence, we are going to make use of the sine. Are you getting it? We are going to use sine 30 degree. Sine 30 degree is equals to opposite, which we are looking for. The opposite is x. So I'm going to have x all over the hypotenuse has been given as 8. So I'm going to have x over 8. Are you there? Okay, so I'm going to have x equals to 8 multiplied by sine 30 degree. Okay, sine 30 degree is what? 1 over 2, you know. So I'm going to have x is equals to 8 multiplied by 1 over 2. X is equals to 4 centimeters, you know. So having gotten the value of x as 4, we can now proceed to calculate the value of y. How do you get the value of y? Well, since you know that, please pay attention. You know that the value of x now is 4 centimeters. 4 centimeters. To get the value of y, the total length, listen, the total length from this point, from this point to this point is what? We don't know it, right? We can get the total length using Pythagoras Theorem. Do you know? Please pay attention. What I'm doing is simple. We are asked to calculate the value of the marked angle. Are you getting it? I mean, the marked side. The side that are lettered, that is what we call the marked side. And we know that the value of x is present here. So we get the value of x using SOHCAHTOA. And the trigonometric ratio that I make use of is what? Sine of an angle. So I got the value of x as 4 centimeters. Now, having gotten the value of x as 4, I need the total length from this point to this point. So, and because I know two sides, I have two sides now. The first side is 8 centimeters, the second side is 4 centimeters. The side that I'm looking for is the adjacent, and I can make use of the Pythagoras Theorem to get the side. That's what I'm talking about. Bring out the triangle. The triangle is this. This is the triangle. 4, 8, and x. X is the adjacent, and we have 30 degrees here. Okay? To get the adjacent, to get the total length, BD, triangle BDA, to get the value of x, just make use of Pythagoras Theorem. According to Pythagoras Theorem, the hypotenuse squared, that is the square of the hypotenuse. 8 squared is equals to the opposite squared. The opposite is this, which is 4 squared. Okay? Don't let us use x. Let us use another letter. Let us use z. Okay? 4 squared plus z squared. 8 squared is 64. 64 equals to 16 plus z squared, because 4 squared will give you what? 16, okay? 64 minus 16 equals to what? Z squared. Are you getting it? Okay? 64 minus 16 will give you 48. Do you understand? So I'm going to have z squared is equals to 48. To get the value of z, you have to take the square root of both sides. So z equals to square root of 48, right? Are you getting it? Now, z equals to square root of 48 can be written as square root of 16 times 3, right? Z equals to 4 root 3. I just leave it in short form, but if you don't want that, you can change it to decimal. Square root of 48 is 4 root 3, and it can also be 6.93. So you can leave it in short form or in decimal form. Are you getting it? Okay. So that is the value of z. Having gotten the value of z, the total length from this point to this point is z, and z is what? 4 root 3. Okay. Now, to get the value of y, let us calculate the shortest distance that is present here from this point to this point. Are you getting it? If I know the distance from this point to this point, I can subtract the distance from this point to this point from this and get the value of y. Are you getting it? Because the total length from this point to this point is what? 4 root 3. Are you getting it? Which is what we calculate as z. So to get the distance from this point to this point, we are going to make use of triangle ABC. Do you understand? Okay, from triangle ABC, triangle ABC, this angle is what? 60 degrees, right? Okay, and this is what? 4 centimeter. This is 8 centimeter. Okay, we are looking for the value of let us call this one t. Okay, we are looking for this side. Oh, sorry, this is not 8 centimeter. Please pay attention. Triangle ABC is this triangle, the smallest triangle that is there. Do you understand? This triangle, that is what I'm talking about. Triangle ABC is this triangle, okay? So we don't know the value that is here, but we can easily determine the value of t using trigonometric ratio. Now, we know the opposite as this. We are looking for the adjacent. Do you know? So what trigonometric ratio are we going to use? We are going to make use of twa. Do you understand? Because we know the opposite and we are looking for the adjacent. Do you understand? So for this, I'm going to have tan theta. Theta is now 60 degrees. It is no longer 30 degrees because the triangle that we are considering now is what? Triangle ABC. Do you get it? So tan 60 degrees is equals to opposite, which is 4, all over adjacent, which is t. Okay, t is equals to 4 divided by tan 60 degrees. Tan 60 degrees will give you root 3. Do you understand? Okay, tan 60 will give you root 3, but you can change it to decimal. Just press. That is what? 1.7321. Okay, so t is equals to 4 divided by 1.7321. That is 2.3093. 2.3093. That is the 2.3093. So you can approximate to 2 decimal place. That is 2.3. I mean to 1 decimal place, or 2.30. Okay, so the value of the distance from this point to this point is what? 2.30. Do you understand? Okay, now we know that from this point to this point is what? 4 root 3, right? Or 6.93. Now we can easily get the distance from this point to this point, which is the value of y. To get the value of y, we are going to have z is equals to t plus y. Are you getting it? Z, the distance from this point to this point is the sum of this and this together. Are you getting it? So to get the value of y, we want to look at how to get it. Since we know that the distance from this point to this point is 4 root 3, that is the value of z, right? And we know that the sum of these two distances will give us this. So z is equals to t plus y. Okay, to get the value of y, make y the subject of the formula. Y is equals to z minus t. So y equals to z. Z is 4 root 3. Okay, 6.93. 6.93 minus t. T is 2.30. So I'm going to have 2.30. So the value of y is equals to 6.93 minus 2.30. That will give us 4.63, okay? That is 4.63. So the value of y is 4.63. I don't want to put it in short form, okay? So it depends on how you view it. If the question says that you should leave your answer in short form, that means that you're going to make use of this value as z. Are you getting it? But if they didn't, if you are not given any condition, just proceed to calculate what you have, okay? So the final answer is 4.63. Now, I'm very sure you can solve this kind of question and you come across it in exam. What of the second question? We are asked to find the value of y and x. How do we get the value of y and x from what we are given? Well, to do that, you can let's start with this one. To get the value of y, we are given that this angle is what? 60 degrees. And this is the angle that we are considering. That means that this side will be what? Opposite, right? Are you getting it? And the side that faces angle 90 degrees is what? Hypotenuse. Do you know? And this third side is what? The adjacent. Do you understand? Okay. So we are given the hypotenuse. We are looking for the opposite, which is y. What trigonometric ratio are we going to use? Yes, we are going to make use of sine. So I'm going to have sine 60 degrees is equals to what? Opposite, which is y. Y over hypotenuse, which is 12. Do you understand? Okay. Y will be equals to 12 multiplied by sine 60 degrees. Do you know? And y will be equals to 12 multiplied by sine 60 degrees is what? 0.8660 or 3/2. Do you know? So for this, we're going to have y equals to 12 times 0.8660. That will give us 10.392. 10.392. And you can also leave it in short form. If you want it in short form, that will be what? 6 root 3 or 6 root 3 or 6 root 3. It's simple, okay? I've already taught you special angle. I've already taught you special angle. From this point, y will be equals to 12 multiplied by root 3/2, right? So y will be equals to 2 here 1, 2 here 6. I'm going to have 6 root 3. If you punch 6 root 3 in your calculator, 6 root 3, 6 root 3, that will be what? 10.392. Do you understand? So it's still the same answer. So the solution to that, the value of y is 6 root 3 or 10.392. Now, how do we get the value of x, which is this point? To get the value of x, it's simple. All you have to do is that, since you know that the hypotenuse has been given as 12 centimeters, we are looking for the adjacent now. What trigonometric ratio combine hypotenuse and the adjacent? That is what? Car. Are you getting it? So I'm going to have cos 60 degrees is equals to adjacent, which is a, I don't know it, which is x. X over hypotenuse, which is 12, okay? Cos 60 degrees is what? Is 1/2. Do you know? So I'm going to have x is equals to 12 multiplied by 1/2, because by the time I take the cross product, I'm going to have x times 1, x, cos 60 degrees times 12. That is 12 multiplied by cos 60 degrees. And we know that cos 60 degrees is what? 1/2. So x will be equals to what? 6 centimeter. Do you understand? Don't forget the unit, centimeter. Do you understand the solution? Okay, so the value of x here is 6 centimeter, while the value of y is 6 root 3. 6 root 3 centimeter. 6 root 3 centimeter. Okay, so that is the solution to that question. Now, let us put the value of y as well. The value of y here is 4.63. Are you getting it? So let us proceed to the next question, which is this triangle. Let me erase this. I can even erase this as well. Okay, now we have triangle ABC. We are looking for the value of x and y. How do we get the value of x and y? Pay attention. Let us bring out triangle ADC. Triangle ADC. So from triangle ADC, I'm going to have something of this type. This one is 90 degrees. This is x. Y, this is 60 degrees. Okay. This is ADC. This side is given as 3 centimeter, okay? So let us put 3 centimeter. In the question, we've been given this side as 3 centimeter. Now, we break down this triangle ADC. To get the value of x, we are given the adjacent, you know, because this will be the hypotenuse, do you know? And this will be the opposite. Now, we are given the adjacent, we are looking for the hypotenuse. What trigonometric ratio are we going to use? Of course, we are going to make use of tan. So, tan 60 degree will be equals to opposite, which is x, over adjacent, which is 3 centimeter. So, all over 3. X will be equals to, now, if you take the cross product, you're going to have 3 times tan 60 degree. Tan 60 degree is what? Root 3. So I'm going to have 3 multiplied by root 3. Do you know? So x equals to 3 root 3. And you can leave it in decimal form. 3 root 3, please pay attention. 3 root 3 will give us 5.196 or 5.196 centimeter. Okay. Now, having gotten the value of the value of x as 5.196, we can go back to replace this as 5.196 or 3 root 3. 3 root 3. Okay. So how do we get the value of y? It's simple. Do you know that this angle is 90 degree? If this angle is 90 degree and this angle is 60 degree, from the bigger triangle, this angle is 90 degree, this is 60 degree. Now, what will be this angle? Sum of angles in a triangle is 180 degrees. So, if you sum 90 and 60 together, you're going to have 450. So, this angle is 30 degrees. Do you understand? Okay. Hence, the angle that I'm having here is 30 degrees. It's simple as that. Okay. Now, if this angle is 30 degrees, let me write it very well. And this side has been given as 3 root 3. Oh, we've calculated this side as 3 root 3. I can bring out triangle ABD. Triangle ABD. Triangle A. Okay. Triangle A. Triangle ABD. This is 30 degrees. This is 90. Now, we are looking for the value of y. And we know that this side is what? 3 root 3. Now, to get the value of y, how do we calculate the value of y? Which trigonometric ratio are you going to use? Since we are given the opposite, because this is the opposite now, and this is what? Adjacent, and this is what? Hypotenuse. We are looking for the adjacent. We are going to use tan again. So I'm going to have tan 30 degree. Tan 30 degree equals to opposite, which is 3 root 3. 3 root 3 all over adjacent, which is y. Okay? So y will be equals to 3 root 3 all over tan 30 degree. Do you know? Now, tan 30 degree will give you root 3 over 3. Do you understand? So I'm going to have y equals to 3 root 3 all over root 3 over 3. You see, I just want to leave my answer in short form. You can decide to leave it in decimal form, you understand? For this, I'm going to have 0.5773. If I don't want to leave it like this, I'm going to have 0.5774. Okay? So 3 root 3 divided by 0.3 root 3. So 3 root 3 divided by 0.5774, that is 8.99. 8.99. So you can put centimeter. That is 8.99 centimeters. So the value of y is 8.99. 8.99 centimeter. Now listen to me carefully. There are some questions that you will be asked to leave your answer in short form. Are you getting it? So please, that's why I'm emphasizing that you should master short. Okay, master sword. I've already did some class on sword. Make sure you visit the video to watch those class. Okay, so the solution to all the question, that's how to, if you come across this kind of question in exam, the best way to go about it is this. Let's consider this question on trigonometry. We are asked to calculate the marked side. Okay, let's start with the first question. We have, okay, let me label it triangle ABC. We are looking for the value of x in this triangle. Now, looking at this triangle, I told you in our previous class that the side that faces the angle 90 degree is called the hypotenuse. Do you understand? And because this is the angle that we are considering, the side that faces the angle that we are considering is opposite. Do you understand? So this is the side that faces this angle. This place will be opposite. And the third side is the adjacent. Do you understand? Okay. Now looking at this, we are given the opposite as root 3. We know that the angle is 45 degrees, and we are looking for the hypotenuse. What trigonometric ratio are we going to use? Okay, the opposite has been given. Opposite is equals to root 3. The hypotenuse is what we are looking for, that is x, and theta is now what? 45 degrees. Okay, what trigonometric ratio are we going to use to calculate the value of x? Okay, that will be what? Sine. So I'm going to have sine 45 degrees is equals to opposite, which is root 3, all over hypotenuse, which is x. Do you understand? Okay, so x will be equals to root 3 all over sine 45 degrees. Do you understand? Sine 45 degrees is root 1 over root 2 or root 2 over 2. Sine 45 degrees, check it. It's 1 over root 2 or root 2 over 2. Do you understand? But notwithstanding, you can leave your answer in decimal. That is what? 0.7071. Okay? You can put your answer in decimal. So I'm going to have, but because, listen, because you're given this in roots, just leave your answer in short form. Okay? So x will be equals to root 3 all over 1 over root 2. Do you understand? X will be equals to root 3 divided by 1 over root 2. X will be equals to root 3 multiplied by root 2. Do you understand? Okay, x will be equals to root 6. Do you understand the solution? And if you don't want to use this value, do you know that? Listen to me carefully. If you don't want to use 1 over root 2, sine 45 degrees is also the same thing as root 2 over 2. Are you getting it? So you can make use of another one. I'm going to have root 3 all over root 2 all over 2, right? I'm going to have root 3 divided by root 2 all over 2. Do you understand? So for this, I'm going to have root 3 multiplied by 2 over root 2. Do you get it? Okay? I'm going to have 2 root 3 all over root 2. Do you understand? Now listen to me carefully. When you get to this point, you are going to rationalize. Do you understand? And if you want to rationalize, you are going to multiply both the numerator by root 2 and the denominator by root 2 as well. So if you rationalize, you are going to have something like this: 2 root 6, because when you are taking the product of two surds, you are going to multiply the irrational part with the irrational part. Are you getting it? So root 3 will multiply root 2. I'm going to have root 6, and then root 2 times root 2 will give me what? Root 4, and the square root of 4 is 2. So I'm going to have this over 2. So this 2 will cancel this 2. I'm going to have what? Root 6. So it doesn't matter the one that you choose, you are still going to have the same answer. Okay? That is, I just show you that one so as not to be confused, because if you punch sine 45 degrees in your calculator, you're going to have root 2 over 2. It's still the same, okay? 1 over root 2 is the same thing as root 2 over 2. The only thing is that the calculator has been programmed in such a way that it will rationalize it itself. It will rationalize the denominator. If you rationalize this sort, you are still going to have root 2 over 2. Do you get it? So that's it. Let me erase this. So the value of x is root 6. Now, having gotten the value of x as root 6, okay, we are done with that solution. That is for question number 1. Let's look at the second question. This is the second question. Now, we are looking for the value of x in this question. We are given this this quadrilateral, okay? Let me call this one A, B, C, D. In this quadrilateral, we have two triangles, you understand? We have triangle ABD, and we also have triangle ACD. Do you understand? Okay? You know, this length, listen to me carefully. This length that you see here belongs to both triangle ABC and triangle ACD. Are you getting it? But from triangle ABC, from triangle ABD, we have been given the a side as 3 centimeters. Do you understand? So we are going to make use of this triangle to get the value of x. Are you getting it? You see, listen to me carefully. X is the length that comes from this point to this point, right? Now, if we are having two triangles, if I want to get the value of x with respect to the second triangle, which is triangle ACD, I'm not giving any side. Are you getting it? But from triangle ABD, I've been given that this side is what, 3 centimeters. So it is easier to get the value of x through triangle ABD. Do you understand? So a more excellent way to go is to bring out triangle ABD. Triangle ABD. Okay? So this is 90. This is x, you know, and this is 45 degree. It's simple, okay? You see, I just will draw the triangle like this. You can you can draw it out anyhow. You can draw it like this. It doesn't matter, okay? This is 45 degree. 45 degree. This is angle 90. This is 3 centimeter. This is 3 centimeter. You know, so it doesn't matter the way you draw it. Just make sure that you are able to identify the sides, and that's why I take time to explain that in our previous class. That the side that faces angle 90 degree is hypotenuse. So this side will be what? Hypotenuse. Hypotenuse. Okay. Now this is the angle that we are considering. The angle that we are focusing on is 45 degrees. So the side that faces angle, the angle that we are focusing on is the opposite. So this side will be the opposite, while the third side is the adjacent. Do you know? So now, with respect to what we have on the board, we are looking for the hypotenuse. Hypotenuse is x. The opposite is what? 3 centimeter. Okay, and we are given that theta is what? 45 degree. Okay, now to get the value of x, what trigonometric ratio are you going to use? You are going to make use of sine. Do you understand? So for this, I'm still going to have sine 45 degree equals to opposite. Opposite is 3 now. 3 over what? Hypotenuse. The hypotenuse is x. Do you know? So I'm going to have 3 over x. To get the value of x, you have to cross multiply. Okay, so I'm going to have x is equals to 3 all over sine 45 degree. Or should I do it step by step? Let's do it step by step for the sake of those that doesn't understand. Let's do it step by step. Sine 45 degree times x, that is what? X sine 45 degree equals to 3. Okay, I just cross multiply. I take the cross product. Are you getting it? Now, to get the value of x, you divide both by sine 45 degree over sine 45 degree. Okay, x is equals to 3 all over. Now sine 45 degree is what? 1 over root 2. So I'm going to have 3 over 1 over root 2. And you can also use decimal. You understand? The question does not specify that you should leave your answer in short form, or so you can use decimal. That is, sine 45 degree in decimal point will be 0.7071. Do you get it? So you can make use of any method that you want, because the question doesn't specify. But me, I prefer this method. Okay, so x will be equals to 3 multiplied by root 2 over 1, because if the division sign changes to multiplication sign, this root 2 becomes the numerator, and while the 1 will become the denominator. So the value of x will be equals to 3 root 2 centimeter. Hence, we have gotten the value of x as 3 root 2 centimeter. And if you want to make use of decimal, you are going to have 3 divided by 0.7071, and that will give us 4.2426 or 4.2427, depending on the decimal point that you the decimal place that you want. Now let us check 3 root 2 centimeter. 3 root 2. What will be the answer? That's also 4.2426. You see now? So it doesn't matter the form that you leave your answer. If the question does not specify, you want to leave your answer in any way that pleases you. But before that, please pay attention to the parameters that you are given in the question. Look here. We are given that opposite is root 3 here. That is why I leave my answer in root as in form of radicals. Are you getting it? That's why I leave my answer in solid form. If I only have 3 here, I can leave my answer anyhow. But because I have a radical, I have an irrational 3. I have root 3 here, so I just have to leave it in root 6. And I just have to leave the value of x as root 6. Are you getting it? So if you are solving it, if you are dealing with exam question, pay attention to the units and the parameters that you are given in the question. Okay. Now, so we are done with the second question. Let's look at the third question. We have this triangle. For the sake of explanation, I'm going to label it A, B, C, D. Okay, I labeled it because I want to explain to you. Now, we are looking for the value of two sides, this side and this side. We are given that this angle is 60 degrees. Let me check if the diagram is correct. Okay, the diagram is correct. This should be 6 centimeter. This side is 6 centimeter. Okay, so this is the correct diagram. Okay, now we are looking for the value of x and y. This x that you see here is this line that comes from this point to this point, and that is the line that joins the two triangles. Do you know? This side is the line, is the side that joins triangle ABD and triangle BDC or BCD. Okay, from triangle ABD, this is triangle ABD, from triangle ABD, this triangle. Let me draw it. Let me draw it in such a way that it fits this side. Triangle ABD. This AD is what, 6 centimeters. So this is 6 centimeters. AD is 6 centimeters. This side is X. So, and the top here is B. The angle that we are given is 60 degrees. Okay. So, what are we looking for? We are looking for the value of X. Okay. Now, listen to me carefully. Let us identify the side. This side is what? The opposite, because that is the side that faces angle 60 degrees. Okay, because this is 90 degrees. This side we got hypotenuse, because that is the side that faces the angle 90 degrees, and the third side is the adjacent, which is this side. Okay, now having identified the side, let's look at what we are given. We are given the adjacent. Adjacent is what? 6 centimeters. Okay, and the opposite is what we are looking for. Opposite is what? X. Now theta, which is the angle, is what? 60 degrees. Okay, now with respect to the information that we are given in the question, we are looking for the opposite. We are given the adjacent. We are given that theta is 60 degrees. What will be the trigonometric ratio that we are going to use with respect to the information that we are given? We are still going to make use of TOA. We are going to make use of tan. You understand? So tan 60 degrees. Tan 60 degrees will be equals to opposite, because tan is TOA. Do you know? Tan is TOA. Tan 60 degrees is opposite. Opposite is x over adjacent, which is 6. Okay. Hence, I'm going to have x is equals to, just take multiply, you understand? Because multiply, I'm going to have 6 tan 60 degrees. X is equals to 6 multiply equals 3. Because tan 60 degrees is equals 3, okay? So x is equals to 6 root 3. Do you understand? Okay? So that is the solution to the third question, which is this. But we are not done with the question. We only get the value of x, we still need the value of y. Okay, so to get the value of y, this is the side y. You understand? This is side y, and side y belongs to triangle BDC. Do you know? Yes, side y belongs to triangle BDC. BDC. So let us draw out the triangle. This is the triangle. Do you know? This is the triangle. We have already gotten the value of x as 6 root 3. Okay, listen to me carefully. You can put your answer in decimal, you understand? In decimal, 6 root 3 will be, in decimal, 6 root 3 will be 10.3923, you know? So, but I just prefer in short form, so I leave the answer like this. So this side is 6 root 3. We are looking for the value of y, and we know that this is b, this is d, this is c, and this is what? 90 degrees, okay? Now, let us identify the sides. This is 90 degrees. The side that faces 90 degrees is hypotenuse. Okay? Please pay attention. To get the value of y, we need to know this angle or this angle. Listen to me carefully. Before you can calculate the value of y, you have to make use of any trigonometric ratio. It's either you use sine, cosine, or tangent, you know. Now, but what tangent, which angle are you going to use? So, we need one angle, either of this angle or this angle. So let's go back to the question. From this question, this angle that you see here is alternate to this angle. That is why this angle is 90 degrees and this angle is also what? 90 degrees. Do you know? This angle is also alternate to this angle. Do you understand? So I know that this angle is 90 degrees, this is 60 degrees. If I know the value of this angle, I can get this angle. Okay? So if this is 90 and this is 60 degrees, and this is maybe angle theta, let us call it angle theta. This theta is alternate to this theta. Okay, because alternate angles are equal in plane geometry. Do you know? Now, to get the value of theta, I'm going to use sum of angles in a triangle. Are you getting it? So according to sum of angles in the triangle, theta plus 60 degree plus 90 degree equals to what? 180 degree. Okay, so theta plus 150 degree is equals to 180 degree. Theta is equals to 180 degree minus 150 degree. Theta is equals to 30 degree. So this angle that you see here is 30 degree. Okay, this angle is also what? 30 degree, because alternate angle are equal. Do you understand? Let me write it very well. 30 degree, alternate angle are equal. So this angle is 30 degree. Okay, if this angle is 30 degree, this angle is 60 degree. Okay, now we can make use of either of this angle or this angle. If you are considering this angle 30 degree, please pay attention. It's simple. Okay, all this thing is simple. Okay, these are basic trigonometry that you're supposed to know. Okay, so just pay attention. I'm very sure you understood how I got this angle as 30 and this angle as 60. Okay, now if you want to make use of 60 degree, you can use any of the angle to get the value of y. I told you. If you want to make use of angle 60 degree, the side that faces angle 60 degree will be what? Opposite, because I told you that the side that faces the angle that we are considering is the opposite in our previous class. So that means that the third side will be adjacent. Do you understand? No matter the angle that you use, you are still going to arrive at the same answer. That is the summary of what I'm telling you. Okay, so let us use 60 degree. Now we are given the opposite and we are looking for the hypotenuse. Are you getting it? Which trigonometric ratio are we going to use? So theta equals to 60 degree. We are given the opposite. Opposite equals to 6 root 3. Oh, we are not even given the opposite. We calculate it by ourselves, you know. X is 6 root 3. So the opposite is 6 root 3. Now we are looking for the hypotenuse. Hypotenuse is equals to y. Okay? Let me erase this. I'm very sure you are done writing that. So I can erase it. Okay? Now we have the hypotenuse as y. Now we are going to make use of sine. So I'm going to have sine theta. Theta is 60 degrees. So I'm going to have sine 60 degree equals to opposite. Opposite is 6 root 3 over hypotenuse, which is y. Okay? To get the value of y, I'm going to have y sine 60 degree is equals to 6 root 3. Do you know what I did? I just cross multiply. Are you getting it? So y equals to 6 root 3 all over sine 60 degree. Are you getting it? Okay, y equals to 6 root 3 all over root 3 all over 2, because sine 60 is root 3 over 2 according to special angle. Are you getting it? So I'm going to have here y equals to 6 root 3 divided by root 3 all over 2. Y equals to 6 root 3 multiplied by 2 over root 3. Okay, are you getting it? Y equals to, now 6 times 2 root 3. 6 times 2 is 12. I'm going to have 12 root 3 all over root 3. Okay, this will cancel this. So I'm going to have y equals to 12 centimeter. Okay, so the value of y is 12 centimeter. Do you understand? You can see that it's simple. If you understand the basics, you are good to go. 6 centimeter. 6 root 3 centimeter. So that is the solution to the first, second, and third question. Now, what of the fourth question? Look at the diagram. We are asked to solve for the value of x and y. How do we go about it? To get the value of x and y, let us label. Let's call this one A, let's call this one B, C, and D. Okay? Let's start by, we can get the value of x first. The reason is simply because in triangle ABD, we have been given that this side is what? 6 centimeter. So we can get the value of x from triangle ABD. Let us bring out the triangle ABD. This is x. Oh, sorry, this is 6 centimeter. 6 centimeter x, A, B, and D. Why this is 30 degree? Okay. Now we are considering this angle. Looking at this angle, we know that this side will be what? Hypotenuse. This will be opposite, while this will be adjacent. Are you getting it? So here we are given the opposite. Okay, we are looking for the opposite. Opposite is x. We are given the hypotenuse. The hypotenuse is what? 6 centimeter. Now we are given that theta is what? 30 degree. Okay, now given the parameters here, what are we going to combine? What trigonometric ratio are we going to use to find the value of x? Okay, that is what? Tan. Okay, no, sorry, that is sine. Okay, sine theta equals to opposite, which is x, all over what? Hypotenuse, which is 6. Now theta is what? 30 degree. Okay, and we all know that sine 30 degree is what? 1 over 2. So I'm going to have cross multiply. I'm going to have x equals to 6 multiplied by sine 30 degree. So 6 multiplied by 1 over 2, x equals to 3 centimeter. Okay, so we have gotten the value of x as 3 centimeter. So this side is 3 centimeter. Now we can now proceed to calculate the value of y, because we have gotten the value of x as 3 centimeter. Just bring out triangle BCD. Are you getting it? You know, when I want to calculate the value of x, I have been given this side as 6 centimeter, so it is easier to get the value of x as 3 centimeter. Now we want to get the value of y. Now to get the value of y belongs to triangle BCD. So bring out triangle BCD. This is the triangle BCD. This is triangle. This side is 90, and this is 45. This is y, and this is what? 3 centimeter. Okay, this is triangle BCD. Okay, in triangle BCD, this angle is 90 degree. So this side that faces 90 degree is what? Hypotenuse. This will be hypotenuse now. Do you understand? And we are considering 45 degree. So the side that faces 45 degree is what? Opposite. And the third side is what? Adjacent. Okay, now looking at this, which side are we looking for? We are looking for the opposite, right? Yes. So to get the opposite, okay, opposite equals to y. Hypotenuse has been given as what? Oh, hypotenuse is calculated as 3 centimeter, and theta is what? 45 degree. Okay, given this parameter, what trigonometric ratio are we going to use to get the value of y? We are still going to make use of sine. Do you understand? So I'm going to have sine 45 degree. Sine 45 degree is equals to opposite, which is y, over hypotenuse, which is what? 3. So I'm going to have y over 3. Okay, sine 45 degree is what? 1 over root 2 or root 2 over 2. Do you understand? So let us make use of 1 over root 2. Sine 45 is 1 over root 2. 1 over root 2 is equals to y over 3. Okay, you can cross multiply. I'm going to have, listen, y times root 2, that is y root 2, equals to 3 times 1, that is 3. Okay, to get the value of y, divide by 2. I mean root 2. Y equals to what? 3 over root 2. Do you understand? 3 over root 2. Now you can rationalize. You understand? Rationalize this. I'm going to have y equals to 3 root 2. Sorry, 3 root 2 all over 2. That is the value of y. And listen to me carefully. When you get to this point, okay, you might be wondering that I quickly substitute the value of sine 45 degree as 1 over 2. You can do it the other way. Just cross multiply here. I'm going to have y times 1 is what? Y. And also, listen, 3 times sine 45 degree, that's what? 3 sine 45 degree, right? So y equals to 3 multiplied by sine 45 degree is what? 1 over root 2. So I'm going to have multiply 1 over root 2. So y equals to 3 over root 2. And when you rationalize, you're going to have y equals to 3 root 2 all over 2, which is also the same as what we have here. Do you understand? Okay, so, and you might be thinking of changing this to decimal. That will be what? Y equals to 2.1213. Y equals to 2.12 centimeter. Okay, so it depends on you. You can change it to decimal. If you want to leave it in decimal, you're going to have something like this. And if you want to leave it in short form, you're going to have this, put centimeter. Okay, so we are done with this question. Now we have 2 questions left. Do you want to try it? Okay, let me solve this one. Then I will give you the privilege to try this one. Then drop your answer in the comment section. Do you understand? Okay, let me erase the board. Okay, so we have this diagram. We are looking for the value of y. Okay, let us label A, B, C, D. In this diagram, we are having two triangles. The first triangle is triangle ACB, and ACD. The second triangle is triangle ABD. Okay. Now we cannot get the value of y without knowing the value of this side. Are you getting it? We cannot get the value of y without knowing this side. So let us get this side. But please, I want you to pay attention. There is another. They give us this side as 7 centimeter. I made a mistake while drawing the diagram. Okay. This side is also given as 7 centimeter. Do you understand? Okay. Back to the question. This is the correct diagram for the question. Okay. Now we want to calculate the value of y. I told you that you cannot get the value of y without knowing this side. Do you understand? So let us get the value of this side. Let us bring down triangle ACD. From triangle ACD. Triangle ACD. Bring out the triangle. This is triangle ACD. This is 12 centimeter. This is 5 centimeter. And let us represent this one as A. Are you getting it? Now, to get the value of A, this side is what? Hypotenuse. Are you getting it? And let's focus on this angle. This side will be what? Opposite. Do you know? And this will be what? Adjacent. Do you understand? Okay. To get the value of the hypotenuse, we are going to make use of the Pythagoras Theorem. And according to Pythagoras Theorem, hypotenuse squared equals to opposite squared plus adjacent squared. Do you know? So hypotenuse is A. A squared is equals to 12 squared plus what? 12 squared plus 5 squared. Okay. A squared equals to 144 plus 25. Okay. A squared is equals to 169. Okay. A equals to square root of 169 is what? 13. A equals to 13 centimeter. Okay. So this side is 13 centimeter. Now, having gotten this side is 13 centimeter. 13 centimeter. Now we can bring out triangle ABD. Triangle ABD. Triangle ABD. This is the triangle. This side is 90. And this side is 7 centimeter. This side is 13 centimeter. And this is A. This is B. And this is D. This is the second triangle. Triangle ABD. Do you understand? And this side that we are looking for now is Y. Do you understand? Okay. Now looking at the triangle, this side is what? Hypotenuse, right? Are you getting it? So if you are looking at this angle, this is opposite, but this is the adjacent. Do you understand? It doesn't matter because we are using Pythagoras Theorem. We always know that the square of the longest side or the hypotenuse is equal to the sum of the square of the other two sides. Do you understand? So it doesn't matter whether they gave you angle here or not. Just master the formula. Okay. Now, hypotenuse squared, that is what 13 squared is equals to opposite squared. Opposite is y plus adjacent. Adjacent has been given as 7 centimeter, 7 squared. Okay. 13 squared is 169 equals to y squared plus 49. Are you getting it? Because 7 squared will give you 49. The next step is that you have to collect like terms. Are you getting it? So for this, I'm going to have y squared is equals to 169 minus 49. Do you understand? What I did was that I just take this 49 to the other side, or I subtract 49, but I subtract from 49 from both sides. Okay. So y squared is equals to 120. Okay. To get the value of y, you take the square root of both sides. So y equals to, now the square root of 120 will give you 2 root 30. 2 root 30. So I'm going to have here 2 root 30. Listen to me. Listen. This is how I get this. 120 can be written as square root of 4 times 30. Do you know? That's equal to square root of 4 times square root of 30. Square root of 4 is 2, so I'm going to have 2 root 30. Do you understand? That's how I got 2 root 30 here. But notwithstanding, if you don't want your answer in short form, you can put your answer instead in decimal. 2 root the square root of 120. Sorry. The square root of 120 will be 10.95. 10.95. So y equals to 10.95 centimeter. Do you understand? Okay, you can see that it's simple. Anytime you come across trigonometric question, just look at the parameters that you are given. Then from the parameters that you are given, you can calculate what you're asked to calculate. Okay, so look at the next question here. We are looking for the value of y as well. How do you get the value of y? You can see that the question is likely the same. This is 12 centimeter, this is 5 centimeter. To get this one, this will be what? 13 centimeter. And y will be what? 10.95 centimeter as well. No matter, they just restructure the diagram and give you. So you can try this one and then give me your answer in the comment section, okay? So that will be all for this class. And before you go, please don't forget to hit the subscribe button and click on the like button. Share the video, drop your comments. Are you getting it? See you in the next class. By the way, our next class will be on bearing, so you can't afford to miss that class, okay?